Hello everyone, welcome to IMS GATE Academy. We are here with the Gate Booster session and I hope everyone is doing great. Already we have started for the mathematics. Now we are starting our subject engineering mechanics, okay? And this engineering mechanics will be what common for mechanical and civil engineering both, okay? So all of you, I will share the session to your friends so that they will also get benefited from this particular session, okay? So engineering mechanics will be discussing, right? And see what is overall structure of this particular session. We'll be discussing most important concepts and as well as the numericals, related numericals, right? Because anyhow, directly solving numericals without any discussion of the topic or the concept, it will not be what, it will not give us that clarity. Okay, for the clarity, we'll also discuss the concept also, right? So most important and advanced levels questions we'll be discussing. Will not solve any PYQ, will solve entirely different set of questions. Okay, that will boost your preparation, right? Already you have solved PYQ, that is sufficient, but to score higher marks we need to put efforts in the advanced level questions also, right? So we'll start the session. Okay, we'll start the session here. So topic, as you know, the engineering mechanics is there, and see, this is the first session. First we'll cover the common topics for both mechanical and civil engineering, right? Okay, topics which are what common for mechanical and civil, right? So see, topics for this particular sessions are the equilibrium, right? Truss, friction, moment of inertia, and the free vibration case. Okay, right? So these are the topics that we are discussing. Okay, this is the topics that we are discussing. Okay, and the mechanical, specifically for the mechanical, second session will be there, but this is obviously it was what common for both mechanical and civil as well, right? So we'll start the session with the topic equilibrium. Okay, we'll start the session with topic equilibrium, right? Now see the topic equilibrium. Now first of all, try to understand what is equilibrium. Okay, what is equilibrium? So when I say equilibrium in general sense, I will talk about like this. It is a state of balance condition. It is a state of balance condition, right? So whenever a balance condition is there, we'll call it by the name of equilibrium. Okay. Now before discussing this equilibrium of any particular body, first of all we need to understand what are the different types of bodies that we are dealing in engineering mechanics. Okay. Two bodies, specifically two bodies we are discussing, particle and a rigid body, right? So we need to understand how we can do analysis of a particle and how we can do analysis of a rigid body. Okay, so first of all we'll discuss the equilibrium. As I said, equilibrium is nothing but the state of balance condition, right? State of balance condition. Okay, it is a state of balance condition. Now, so when we talk about equilibrium, we need to understand which type of system, which type of body we are discussing. Okay, right? Okay, so Rahul will discuss the doubts later on, but first of all, try to focus on the topics and the concepts that we are discussing, and between the lecture, we'll discuss your doubts also, right? So see, balance condition, it is clear. Now we have to understand which type of systems we are dealing. See, first system will be what we calling that particular system as what particle. Two things are there, particle, and second one is the rigid body, right? Rigid body. So try to understand how we can deal with rigid body and with the particle. Okay. So when we talk about the particle, try to understand it is a point size body. We have neglected or we have ignored the dimension of a body, right? So whenever particle is there, okay, whenever particle is there, which type of force system will be applicable? Concurrent force system will be applicable for the particle. Okay, always a concurrent force system will be applicable. Okay, try to understand this point. Concurrent force system will be applicable always for a particle. Okay, there will not be any kind of moments. Okay, because there is only point is there, so how the moment will be there? Okay, so this is what very important point. Only concurrent force system will be applicable for the particle. Now for the rigid body, obviously the dimensions will be there. For that we'll have a non-concurrent force system. Non-concurrent force system. Okay, so that is what a very important point. Okay, so Rahul, one more motivation required. See, Rahul, obviously, see, you need to concentrate on your semester exams as well as or the gate exam also. Okay, So you have to take both the things parallelly, right? But during the semester examination, you can you can just do the revision only, okay? And after your completion of this semester examination, you can again start your efforts in giving this test series part. So AMTS mock test series, that is what we are having, a very important test series. If you follow those test series, obviously your preparation will be what, in a advanced level, right? So whenever your exam is there, just revise your subjects whenever time is available to you, and after that try to give the AMTS mock test series only, right? So don't worry about that. So we have the different tasks. Obviously many students will face this problem, right? Okay, so for that you can contact the support team, okay? That is not an issue here. Now see, come back to the topic part. So particle and rigid body, two things are there. So as we have discussed, concurrent force system in particle, non-concurrent force system in rigid body, right? Now try to understand this point. So whenever concurrent force system is there, okay, see, concurrent force system basically means the point of application of the forces will be what, same. But whenever we have non-concurrent force system, see, let's suppose this is the body, point of application will not be same. Okay, point of application will not be same, right? Different point of applications will be there. Okay, now try to understand what are the equilibrium conditions for particle and rigid body. That is we need to understand here. Okay, so when we see the different conditions, okay, you need to understand the conditions only. Equilibrium conditions: summation of forces along x direction equals to 0, summation of forces along y direction equals to 0. See, actually we are dealing with coplanar force system, so we'll discuss only two dimensions, x and y. 2D case we'll discuss. So as there is no possibility of moment, the moment equilibrium will not consider here. But for rigid body, we need to consider moment equilibrium as well, right? So summation of forces along x direction equals to 0, summation of forces along y direction equals to 0, and summation of moment about any point is 0. So these are the three conditions for rigid body, and these are the two conditions for the particle case. So that is all we need to solve any question from equilibrium topic, right? That is what very important point. So that is two conditions for particle, three conditions for rigid body. Okay, that is what we need here. So I hope this is clear. Now moving on to the next part, we'll discuss the numericals here. Okay, various type of numericals are there in this equilibrium topic. Okay, we'll discuss one by one. Different numericals are there. Y to xz. This is one of the question that you need to solve. Okay, so again, very basic question, I would say. This is what a basic question. Okay, and I want you to answer this particular question. Okay, everyone please try this question and tell me the answer. Okay, so this is a situation in which a block is what balanced with respect to this different three springs are there. Okay, and they are asking what? They are asking the mass of this particular body. Okay, they are asking the mass of this particular body, right? So obviously they are talking about the equilibrium condition. Considering the equilibrium condition, you need to find the mass of this particular body. Okay, so whenever you are dealing with any engineering mechanics question, you have to draw the free body diagram. Okay, you need to draw the free body diagram. Okay, so just draw the free body diagram and just tell me what will be the answer for this particular question. Okay, just try everyone. Okay, again, see, if you read the question, they have mentioned what the unstretched length. Okay, focus on this point. Unstretched length of spring AB is 3 meter. Okay, so AB is this spring for which they have mentioned unstretched length. Okay, now if the block is held in equilibrium position shown, determine the mass of the block D. Okay, now for this particular condition, equilibrium is maintained. Okay, so right, so if I consider this A, okay, if I consider this A ring, so there will be one spring force here, there will be one spring force here, and there was one weight here. Okay, weight of this particular body. Actually they are asking for the mass, but force, if I consider, that will be what? The weight of the body, right? Now see, for this particular spring AB, a spring force will be acting, that will be equals to kx, that will be equals to kx, right? Obviously simple. And for this AC, there is also a spring force, it will be also equals to kx, but for that we need to know what is x. Similarly, we need to know what is x for this AB spring. Okay, but as they have mentioned unstretched length, and this is the actual condition of the length, if we take the difference, we'll get the answer. Okay, we'll get the answer. Now try to understand this point. So let's suppose for the AC, if I put tension T as it is, okay, if I put tension T as it is, so now try to understand. So let's suppose if I draw the coordinate system as well here. So now if I want to calculate this x, what will be the x? See, K value they have already given 30. Okay, into x. What is the x value we have? Original length is what? The 3 meter they have mentioned. Now it is what? AB. If you see the Pythagoras theorem, okay, this is 4 dimension, this is 3 dimension. AB will come out to be, if you use Pythagoras theorem, it will be what? 5. So 5 is the now deformed condition length of this spring. 5 minus 3 will be the x value. 5 minus 3 will be the x value. Okay, so just take the difference. 5 minus 3, you will get the answer here. Okay, so that is what the force we are having. Clear? So that is this force. Okay, now see, you can apply this Lami's theorem here also. Okay, it's your choice if you want to apply the Lami's theorem. That is what you can do here. Otherwise, you can use the equilibrium equation summation fx0 summation fy0. That is you can do here. Okay, but before applying Lami's theorem, you need to know what is the angles. Okay, what is the angle here? Okay, so as this is 3, this is 3, so obviously this angle will be what? 45 degree, right? So this angle will be what? 45 degree. Okay, now if I talk about this angle theta, it will be what? See, perpendicular is what? 3 and the base is what? 4. Directly you can put tan theta. You can put it here like this. Tan theta, perpendicular upon base. Perpendicular is what? This 3 and this is what? Base. So from here you will get the value of theta as well. Okay, right, simple. Theta value you will get. Now see, if I apply Lami's theorem, I can use this kx value divided by, what is the angle opposite to this particular force? Sine 90 plus 45. That is what the angle we are having. Okay, this is the angle. And if I talk about this W, angle opposite to W will be what? Sine. Okay, so total angle will be what? 180. From 180 you need to minus what? 45 plus theta. You need to minus this particular angle and you will get the answer for this W value. Actually from this you will get the value of W, but they are asking what? The mass. They are asking what? The mass. Okay, right. So now see, very important, that is what we have applied the Lami's theorem. After solving this one, see, you will get the answer here. You will get the answer for this W value. Okay, you will get the value of W, and as you know, W can be written as what? Mass into G. From that you will get the value of mass as well. Okay, so just put the values and you will get the answers, right? You will put the values and you will get the answers, right? So I hope this is clear to everybody. See, just apply the Lami's theorem, or even if Lami's theorem is not what clear to you, you can apply simple equilibrium equations as well, right? Simple equilibrium equations you can apply here. So simple equilibrium equations will be what? Like this. You can apply this equations. Summation fx equals to 0, summation fy equals to 0. These are the two equilibrium equations that you can apply here, because the situation is like this. Okay, that is what the force kx. Okay, that is what the tension we are having like this, and this is what the weight W. So simply resolve the forces along x direction, and along y direction. You need to resolve the forces and you will get the answer after resolving these forces. Apply this equation on this one, you will get again same answer only. So it's your choice. So whenever angle is known to you, then it is what? Very easy to apply the Lami's theorem. And always remember, when you are applying the Lami's theorem, what are the important things that we need to understand? First of all, the body has to be what? In equilibrium. Second thing, that only 3 forces will be there. Only 3 forces will be there. Okay, so whenever body is in equilibrium and only 3 forces are acting on the body, then all 3 forces will be in what? Concurrent. All 3 forces will be what? Concurrent. Okay, all 3 forces will pass through a single point. That is what a very important point that we need to understand from Lami's theorem. Okay, so I hope this particular point is clear to everybody. Now, very easy question. Okay, very easy question, I will say. Now we'll move on to the some different question. Okay, some different question we'll discuss here. Okay, but before moving ahead, tell me the answer for this mass here. What will be the value of this mass here? After sorting this one, what will be the value of mass? Tell me, what will be the value of mass here? Okay. Okay, just you need to put the values and you will get the answers. Okay, theta you can calculate from here. Okay, simply what we have put here, this theta we have calculated. Like this is what they have mentioned as 3 perpendicular. This is what the base we are having. So perpendicular upon base is what? Tan theta. Putting the value of theta here, you will get answer. See, angle opposite to F we have taken, angle opposite to W we have taken like this. So from 180 we have minus 45 plus theta. So finally you will get the answer as 8.56. Okay, just you need to check this answer. Finally you will get the answer here. Okay, now moving ahead. Okay, after solving this question, now moving ahead with this question. Okay, this is one of the most important question, I would say. Okay, just you need to apply some basic aptitude part here also. Okay, some basic aptitude part you need to apply here, right? Again, so this is what a very important question. See, if you read the question, they're asking what? See, a rigid thin L-shaped bracket is given, okay, which is fixed to the wall at point B, okay, and a force is applied on point A, that is given here. Now they're asking the maximum clockwise movement when the inclination theta is. So they are asking because of this force, what will be the value of theta, so that we'll get maximum moment at point B. Okay, are you getting the point? They're asking the value of this theta so that you will get a maximum moment about point B. So how you will solve here? How you will solve this particular question? Okay, just try to focus on the point. They're asking, obviously force is there, so some moment will be there because of this force. To get the maximum moment about point B, what we need to do here? Okay, but before getting the maximum value also, first of all you need to understand how you will get the moment of this force about point B. If you write correctly, there will be what? One equation will be there, which is as a function of theta. Then you will differentiate that particular equation with respect to theta, equate to 0, and finally you will get the value of theta as well. Got it? So that is what the concept here. So such type of questions also important in our GATE examinations. Okay, looks like what very simple, but when you try to solve, some mistakes usually happens. Okay, and we have to totally avoid those mistakes as well, right? So if I solve this question, see how I can solve this question. So this is the case. Obviously, whenever I'm writing the moment, see, whenever I'm writing a moment, I need to ensure that F into distance d I'm writing. Okay, that is what the formula we are having. But what is d? D is the perpendicular distance from the line of action of the force to the point of consideration. Got it? So D is the line of action of force to the point of consideration, right? That is what important point. So try to focus on this point. Let's suppose this is the force, and see, we'll have, this is the distance. Let's suppose I'm considering this is the force, and assume this is what the perpendicular distance. Okay, some kind of distance d is there. Okay, this distance is d. Now try to focus on this distance also. From A to B there is also one distance here. From A to B there is also one distance. Now to calculate the moment of F about point B, we will just multiply distance d and this force F, assuming that distance d is the perpendicular distance. Okay, obviously it doesn't look 90 degree, but assume that this distance is what? Perpendicular. Yes, very good. Line of action of force, then only we'll get the answer, no, for the maximum bending moment. Okay, so always remember, whenever you are writing the moment, the distance d has to be what? The perpendicular. Distance d has to be what? Perpendicular. Now, so see, first of all, AB distance they have given. See, AB distance. AB distance, I can find out AB distance as what? 0.5. Directly apply the Pythagoras theorem, I will get the value of AB as well. AB value you will get as what? 0.5 meter. Okay, AB value will be what? 0.5 meter. Correct. Now we'll get the value of AB here. Okay, 0.5. Can I value of this angle theta? Is that possible for us? What is the value of angle theta? Okay, we'll not call it theta because already they have given theta here. It will make a confusion here. So we'll directly write the value of theta here, whatever the angle is there. Okay, so it is very easy for us to calculate this angle. Okay, we'll put what? Perpendicular upon base 10, phi, we'll call it phi. Phi will be equals to, perpendicular is what? 0.3 and base is what? 0.4. So from this you will get the value of phi as well. Okay, simple. Same phi will be here also. This is also a phi here. Okay, now, so if you see a triangle A, B, C, let's suppose this point is what we are having as C. So in triangle ABC, if I apply sine rule, so I can write D divided by angle opposite to D will be what? Theta plus phi. Okay, theta plus phi will be there, equals to, if I take then AB, angle opposite to AB will be what? Angle opposite to AB. Okay, angle opposite to AB will be what? This, the angle that will be what? 90 degree. Okay, so consider this as a, what, 90 degree. Okay, why we have assumed 90 degree? Because to calculate moment we need the perpendicular distance from the line of action of the force. Please distance as what? The perpendicular one. So we'll put the value, because I have 90 degree here and opposite to AB, so I'm taking the value. So from here we'll get the value of D here. AB is what? 0.5 into sine theta plus phi. Okay, phi you can easily calculate from this one. Then phi equals to 0.3 divided by 0.4. Simple. Perpendicular divided by base, you can get the value phi here. So in this equation only unknown is what? Theta. Okay, now to calculate moment, what we'll do? Moment of force about point B. Okay, B is the point where we need to calculate the moment. So force F multiplied by distance D. So that is what we are having as the moment. Now if you put the value of D here, you will get what? F into 0.5 sine theta plus phi. Right? Clear? Now see, this equation contains only one unknown, as phi is known to us. Just by using this particular relation you will get the value of phi as well. Got it? Now see, we'll do what? We'll do the differentiation of moment with respect to theta and equate it to 0. You will get the value of what? Theta, for which the bending, this particular moment will be what? Maximum. Got it? So we'll differentiate. So what is the value of bending moment here? We'll call it simply moment here, not a bending moment, simply moment we'll call it. So it is what? F multiplied by 0.5 into, and what is there? Sine theta plus phi. Sine theta plus phi is there. Okay, so you have to differentiate this thing and equate it to 0. So obviously this is what? Constant. F is constant, 0.5 is again constant. It will become cos theta plus phi. Okay, so cos theta plus phi will become 0 when the theta plus phi angle equals to what? 90 degree, because cos 90 is what? 0 here. So from this one you will get the value of theta. Phi is known to us, right? Phi value is known to us. Just simply calculate the value of phi from here and put the value of phi here, and you will get the answer. Okay, so just tell me what will be the answer here. Everyone please try to answer here. What will be the answer? Okay, what will be the answer here? Right? 53 degree. Yes, 53 degree. See, actually if you calculate this phi value, no, it is coming out to be 36.87 degree. It will come out to be 38.7, and if you value here, obviously complementary angles it will be there. So 53.13 will be the what's actually the correct answer here. Okay, so the answer will be what? 53.13. Okay, so that is what the answer here. So that is, see, again try to understand the concept here. So whenever you want to write the moment, everyone knows the formula of moment, F into D, force multiplied by the distance. But the concept here is that D is the perpendicular distance from the line of action of force to the point of consideration, right? So Saurabh has got the correct answer here, right? Okay, so okay, we'll move on to the next part here. Okay, now see, again, see, this is what, again, very important question. But before solving this question I want to discuss the concept here. Okay, that is what very important for you. Okay, we'll discuss a concept here before going to this part. The concept will be what? Resolution of a force into force couple system. Okay, we'll discuss this concept here, very important. Resolution of force into force couple system. Okay, that is what very important concept here, resolution of force into force couple system. Now see how we can resolve a force into force couple system. Okay, now try to understand. So let's suppose a random body we have assumed. Okay, a random body we have assumed. On this random body we will have this thing, a force is acting, right? So let's suppose this is what a force we are having, F. Okay, now at this point A, let's suppose any point we can assume. It is not like that is the only point that we need to understand or consider. Any point in the body you can consider, right? So let's suppose I have considered this point A. So at point A, I want to convert this force into force couple system at point A. Okay, like that we want. I want to convert and non here to here with force couple system, right? How we can do that? See. So simply this is the body again. See what we will do. What we'll do here. See, this is point A. In point A, we will have this thing. See, point A will apply the force F in equal and opposite direction, and this is what we are having as a force F. So obviously, because of this force system, okay, because of this force system, there will not be any change in the system. System will remain in same condition. Condition of a system will remain same as it is. Condition of a system will remain as it is, right? So if I replace, see this force and this force will create what? You need to answer here. Very important point. This force F and this force F will create what? A couple here. It will create a couple, and when it will create a couple, obviously a moment value will be there for this couple. Okay, that is what the distance is. What? Let's suppose any distance is there. D distance I'm considering. Distance D multiplied by this value F. That is what the moment value of this couple F and F. What is couple? Two equal forces opposite in direction separated by some distance. It will create a couple here. Okay, the direction of couple will be what? The clockwise, and the moment value of that particular couple will be what? F into D. D is what? A distance between two parallel forces. So this will create a couple here. Okay, that is what it is clear from this particular diagram. Now, so we'll remove that particular force couple system here. This couple into its value. We'll replace this one. See, this force F will remain as it is because this force and this force will create a couple, and for that couple, moment value will be like this. F into D. D is the distance, right, between these forces. So that is what we have resolved a force into force couple system. Okay, so this is what equivalent bodies. Okay, condition of a body is what? Equivalent. But what we have done here, we have replaced this force into force couple system, right? This is clear. And see, whenever a force couple system is there, you can convert into single force. That is also possible. The reverse just you have to do. Is this point clear? So you have converted to force couple system, or you can do force couple system into force system. That is you can do. That is what a reverse process. That is what a reverse process here. So this concept is again very, very important, and you need to understand this concept. Then only you will be able to solve the questions. Okay, now see, the next question we are having based on this concept only, right? I hope the question image is clear to everybody, right? The question image is clear. So they have said a rigid square ABCD, a rigid body or rigid plate is there ABCD subjected to planar forces at the corner as shown in figure. So at the corner B, this is force P. At corner C, this is force. This is the corner D, which is acting at force P, right? So at the corners, forces are acting. Now they are asking what? For this planar force system, equivalent force couple system at corner A. This is a force system which is given to us. Now they are asking equivalent force couple system at corner A. So whatever the concept just now we have discussed, based on that only you have to answer. Okay, right? I hope this is clear. Now, see, I hope now diagram is clear to everybody. Now see, try to understand. Okay, so this is the force system. Okay, this is our system here. What we need to do? We need to convert this force system into force couple system. At what point? At point A they are asking. So whenever such questions are given to you, what you have to do? Just directly put all those forces on that particular point, maintaining the same direction. Maintaining the same direction. Okay. So let's suppose at point A, this force is acting at point C. Directly you have to put this force at point A. D force is acting like this. So directly put the D force at point A. P force is acting at point B like this. So directly put this force at point A. So step number 1 is what? Directly put all those forces which is acting on the body to the point of consideration. That will be given in the question. In this case, they have given A. So I will put each and every forces on the point. That is what here in this case A. but we have to maintain the direction as well. Okay, whatever the direction is there, same direction we need to apply here. Okay, now see, this is the plate we are having. Okay, now if you put, this is the force P which is acting at point C, at D this is the force. Okay, it will be acting like this, and because of point B force is acting like this, so we'll put up force P like this. Now obviously you will see, sir, this force will be what cancelled out here. Okay, this forces will be what cancelled out, only single force will be there, only single force will be there, that is what P in the downward direction. Okay, so but if you see this options, 4 options are given to us, option A is wrong. Okay, directly option A is wrong, option C is also wrong because the force is in the upward direction, right? Only option B and option D will be what correct with respect to force direction. Now force is clear to us. Now what we have to do, the moment will also be there. No, see, force P is acting at C, so some moment what will have at point A, force P is acting at point B, so it will have a moment at A. So force D is P which is acting at D, now it is past finished, yes, so it will not have any moment. So moment will be there because of this force, because of this force only at point A. This force will not have a moment at point A. Why? Because it is passing through point A. So whenever a force is passing through a point, there will not be any moment. Moment will be there when there is a difference. Okay, when it is not passing through the line of action of the force. Line of action of the force has up say point E, then only the moment, right? What now if you calculate the moment at point A, see, if you calculate the moment about point A, you will get what? See, because of this P, clockwise moment is there, P into A. Okay, because of this force. Because of this force, again clockwise P into A is there. So finally you will get what? 2PA. That is what the moment we are getting. Already direction clockwise direction. What is the answer? This is the answer in which they have mentioned like this. So correct answer here, everyone. Correct answer is what? Option B. This is what option B we are having, and this is the correct answer. Okay, so such type of questions they can have. Okay, so always remember, we can resolve a force into force couple system. Just you need to do what? Please see, this is what very important concept. Okay, try to understand the process here. Force is acting like this, you need to transfer this force to this point. Obviously with respect to force, a couple will also come, right? So what you have to do, a force is acting like this, just you need to put what? Two forces equal and opposite in the point of consideration at point A. Let's suppose this force will create a couple for which the value of moment will be this one, and this is the force. So just in a direct or in a quick way, how you can decide? Simply you have to say, okay sir, this is the body, a force is acting here, F. So at this point I have to transfer this force. What will do? You will say, okay sir, same direction force will be there, and whatever the moment it is whatever the moment of this force is there at point A, directly will mention moment because of because of what? Force F. Moment because of this force F. Directly you will write this. Are you getting my point? So directly you need to write, okay, because sometimes see, it will take lot of time to understand, but whenever a thing is there, okay, whenever thing is there, when concepts are what important, you need to go with the process. Okay, you need to go with the process. Sometimes when we are in a hurry, we'll make some silly mistakes. So you have to go with the process. Whenever you will go with the process, you will not make any mistakes. Correct? So that is the process you need to understand. Force is there, you need to apply these two forces. This force will create a moment couple for which moment value is this one, and this is the force. If you want to go in the reverse manner, how you will do? See, I will say. So let's suppose a case is there, and let's suppose a force is acting F like this, and this is what? A moment which is acting like this at point A. Now I need to convert this force couple system into single force. What you will do? Okay, again see how you can do. Simply draw the body here, same body I have drawn. So see, this force is acting and this couple is there. So obviously we want to convert this force couple system into single force. So when we want to convert this force couple system into single force, we have to ensure one thing: direction of moment. Because anywhere that force will be there. Okay, see, this force can be here and here, it doesn't matter, but what we have to ensure? Direction of moment. So see, this is point A. Okay, so force can be here also, but only this force can have a clockwise moment here. This force cannot have a clockwise moment about point A. So obviously this possibility will be what ruled out. Only this is the force which will have a moment value here in the clockwise sense. Force will be F here. But how much distance? There simply you can take, see, moment value will be equals to what? F into D. So that will be the distance D we will have. Okay. That is what the distance D will have. Moment value already that will be given whenever force couple system is there. Moment value will be given. So moment value is given, F value is given, D you can easily calculate. Okay. So like that we can convert this force couple system into what? Single force. I hope everyone is clear with this concept, right? So this concept is clear to everybody. Again, very important. Okay. Now, moving to the next part. We'll move on to the next part. Okay. Yes, this is the question. Okay. Again, very important question with respect to GATE examination. See, such type of questions you will have in your GATE examination. So in this question, they have mentioned a circular disc. In this question, they have mentioned a circular disc of radius 1 meter subjected to 4 forces as shown in figure, right? Now see, what will be the location of resultant force with respect to point O? Point O they have mentioned here. This is the point O, and they're asking the resultant force with respect to point O. Now, first of all, try to understand. This is a non-concurrent force system. This is what we are having, a non-concurrent force system. So whenever a non-concurrent force system is there, we need to understand what is the procedure so that we'll get what a resultant value of the non-concurrent force system. For concurrent force system, it is what very easy. For concurrent force system, it is what very easy. But for non-concurrent system, we have to careful. We have to be what very careful regarding the location of resultant value, right? So I will explain a small concept here. Then you have to answer this question. Okay, a small concept we'll discuss here. See, after discussion of this particular concept, you should answer this question, right? So I will discuss a small concept here. So right, so let us suppose any number of forces are there. Any random case I am drawing. Okay, so this is the case of non-concurrent force system. I hope this is clear. This is the case of non-concurrent force system. So when it is a non-concurrent force system, okay, how I can find out the resultant value? That is the question. Okay. So first of all, try to understand there step number 1. Step number 1 is that you have to convert this non-concurrent force system into concurrent force system. Okay, how you can do? See, for making this non-concurrent into concurrent, we need what? A point of consideration. Let us suppose this is a point of consideration. This point A is the point of consideration. Okay. Now you will see. Okay, you will see here important point. So what you have to do? See, whatever the forces are acting, directly you have to put at point A, because point A is our point of consideration. Okay, directly put F1 force at point A. So when you will place this F1 at point A, a moment will also be there, a couple will also be there. Got it? So any moment value will be there apart from this F1. In a similar manner, you will put F2 with the same direction. When you put F2 here, or when you place this F2 at point A, a moment will also be there. In a similar manner, directly put F3 here with the same direction. So when you will place F3 to point A, okay, when you move this F3 force to point A, a moment will also come. So like that, a moment value will be there because of F1, F2 and F3 at point A. Okay, that you will calculate. For example, I am considering any random direction. I don't know the direction right now, but I can consider, let's suppose this is the value of summation of moment at point A. Assuming it to be what? Anti-clockwise. Okay, that is we can assume, or clockwise, any direction we can assume. Okay, so now this non-concurrent force system converts into concurrent force system. Okay, now whenever concurrent force system is there, now it is what very easy for us to calculate. It is very easy to calculate what the resultant value. How? See. Now see. So this is point A. So forces are there. Just try to make what? Horizontal. Resolve all the forces in horizontal direction. Resolve all the forces in vertical direction. So when you will do like this, you will get the resultant. How? Resultant formula you know very well. It is like this. I hope you are getting this point very carefully. Okay. This point is clear, right? So now try to understand this point, very, very important. This is the value of resultant that we'll get. So any resultant value you will get like this. Okay, I'm assuming this is the resultant and this is the moment that we have. So again, now try to understand this situation is what? A force couple system we are having. Now you can easily convert this force couple system into single force. That is what required here. That is what required here. So you can easily convert this force couple system into single force. Okay, I hope this is clear to everybody. So now again situation is same. See, like we have discussed earlier also. See, try to understand this particular point. Right? Single force converted into force couple system, or force couple system can also be converted back into single force. So this process very, very important. It will be what helpful in some different numericals, right? So that is what the concept we have discussed. So coming back to the this part that we are discussing, what the resolution of this non-concurrent force system into a single resultant value. So we'll get this one. So now from this force couple system we'll easily get the simple value. What value we'll get? Simply we'll get the resultant. Okay. Now try to understand important point. Try to understand important point here. See. So let's suppose this is the body. Again, this is the resultant we have, and this is the value of moment we are having. So to convert this particular force couple system into single force, what we will do? See, assuming same body. So that is what the point A we are having. So always remember this point. What show the moment direction? So clockwise moment it will have. So this is point A. Either the resultant will be like this or the resultant will be like this. See, by observing the direction or sense of rotation of moment, this case will be what ruled out. Which case? This one or this one? Because we have to ensure what the clockwise moment. So this case will be what ruled out here. Okay, this case will be what ruled out. Only this is the possibility. Now to calculate the location, you need what? This distance. This distance you can easily calculate by using a simple fundamental equation. That is what? R into D will be equals to what? Summation of moment about point A. That is what the Varignon's theorem we are having. Okay. I hope this particular concept is clear to everybody. Very, very important. Till now in the GATE examination, they have never asked this question from the non-concurrent force system. Definitely you will get the question from this non-concurrent force system. Okay, in upcoming years, maybe this year, maybe next year also, but definitely you will get one question from non-concurrent force system. That is what this question. See, concept is this one, right? Okay, so now coming back to our numerical part. See, this is what the numerical we are having. Now to solve this question, we have discussed the concept. Now you have to answer the resultant. Okay, you have to mention the resultant with respect to point O. So resultant you can anyhow calculate very easily, right? Just you have to do what? Simply, see, I will draw this one again for you. Okay. Right. So now see. So for example, this 15 Newton is acting here. 15 Newton is acting like this. 10 Newton will be acting like this. Okay. Again 15 Newton is acting like this. And again a 20 Newton will be acting like this. Right. I hope this is clear. Okay. So what we have done here, we have directly put the forces at point O. 15 Newton directly put here. 10 Newton directly put here. 15 Newton directly put here. 20 Newton directly put here. So we will get the resultant value. So by observing this one, you will get what? See, sir, 15 Newton will be what cancelled out. So 20 plus 10 will become what? 30 here. Okay. 20 plus 10 will become 30 here. So total value of the resultant force is in the direction of horizontal. Direction. That is what we are getting here. So summation of forces along horizontal we are getting as 30, and summation of forces along vertical we are getting as what? 0 here. So that is the point we are getting. But obviously some moment value will also be there. Okay. Because of these forces, we need to calculate the moment also. We have calculated the resultant at point O because we are doing what? We are converting this non-concurrent force system into concurrent. Right? Converting this non-concurrent force system into concurrent force system. So resultant value we know 30. moment value. Next, the step is what? To calculate the moment. Okay, we are doing what? The calculation of the moment part, right? So we'll do here the moment value. Summation of moment about point O will do. Okay, now see. So see, 10 will have what? Clockwise movement, 20 will have anti-clockwise movement, 15 will have clockwise, 15 again will have a clockwise. So radius is given was 1 meter. Radius is given as what? 1 meter. So 15 into 1, 15 into 1, again clockwise sense will do. Okay, that is what the clockwise movement we are having. Okay, this 20, this 10 will also have clockwise. Okay, but 20 will have anti-clockwise. Okay, 10 will have a clockwise movement, but 20 will have a anti-clockwise movement. So like that you can calculate the moment value. So this moment value you will have. Okay, very easy. Okay, very easy. Now see, try to understand. This moment value will got. Okay, this moment value will get here. Moment value is clear, resultant value is clear. Now what you have to do? Use the Varignon's theorem to locate resultant value. To locate the resultant value, we need what? We need what? We need this answer. We'll need what? The Varignon's theorem. For the location of resultant, we need the Varignon's theorem. That is what required here. So simply we have calculated the moment value. Now see, whatever the moment value is there. Okay, so see, we'll use again this cylinder circle here, circular plate. Now see, yes. So so let's suppose this is the point A we are having. Resultant value we got what? 30 Newton. Resultant value is what? The 30 Newton in this left direction. 30 Newton value we are getting. I hope this 30 Newton value is clear, and a moment value will also be there. Okay, moment value you can easily calculate. This 15 and 15 will become 30, and this is plus 10. This is what? Minus 20. You will get what? A 20. So 20 in the clockwise sense you will get. Okay, 20 Newton meter value you are getting like this. So this is a force couple system you are getting. Now to convert this force system into what? Single force. This is a force couple system. Now you need to convert this force couple system into single force. Then only you will get what? The resultant, single resultant you will get. Okay, so for that, see, this 30 Newton is there. Either, again we'll draw the case of circle. We'll draw the circle here. Not an issue here. Now see. So 30 is there. Okay. So obviously, see, two possibilities are there again. Either the 30 will be here or 30 will be here. Which 30 will create a moment in clockwise sense at point O? Only this one, not this one. So this is what? A ruled out case. This case will be what? Ruled out. So again, we'll make a coordinate system so that it will be what? Very easy for us. Okay. So definitely 30 Newton will be acting like this. But to calculate this distance, we need what? The Varignon's theorem. Resultant multiplied by distance d will be equals to summation of moment at point O, that we have what? 20 value. Resultant is 30 into d. The summation of moment is what? 20. So based on this one you will get the answer. Based on this one you will get the answer. So I hope this particular concept is what? Clear to you. Finally you will divide, you will get what? 0.67. 0.67 value you will get. Okay, so we have converted a force couple system into single force, and that is what they are asking in this question. Okay, they are asking what? The location of resultant with respect to point O. So in this case you can mention here this thing. So this is the resultant with respect to O. It is at a distance of 0.67 meter. This is the answer we have. This is the answer. Are you getting the point? This is the answer we have. So like that, a concept is what? Very, very important here. So see, in equilibrium, concepts are what? Limited, but different variety of questions can be framed. Okay, different variety of questions can be framed. But if you are strong at your basic concepts, then it will be what? Very easy to solve any type of questions. I hope this particular part of equilibrium is clear to you, right? So again, this concept is also clear. Now moving on to the next part. This truss, guys, again this is what? Very, very important part. Okay, truss part. Okay, and in the truss, now this is what very easy and scoring one. See, engineering mechanics will become a very high scoring subject for you if you know the basics and if you have solved a sufficient number of questions. Then it will be what a scoring subject for you, because question will become easy when you have applied the concepts, right? If you are good at the basics, you will be what scoring good marks in this particular subject. Okay, and specifically this truss one, very easy, right? So in the truss, directly we'll discuss two important things: zero force members and the method of section. Two important concepts are there in truss chapter. If you know method of section and this zero force concept, you will be what solving any type of question that will be what in your gate examination. Okay, you can easily solve any type of questions. So coming to the concept here, the truss, zero force member, right? Very important, I would say here, because lot of questions you will see both for mechanical and civil. Lot of questions you will see from zero force member. So two concepts are there in zero force member. We'll discuss one by one. Okay, now see, if two non-collinear, okay, just try to focus on the words here. Okay, two non-collinear members form a truss joint here, then you will get what? Then you will get a, see, this is what the truss we are having. Okay, truss will have here. So truss joint and non external load or support reaction is applied to the joint, then the two members must be a zero force member. Okay, so two non-collinear members. Non-collinear basically means some angle between the two members should be there, some angle will be there. So no part and no external loading on this joint, no support reaction at this joint, then what the force, both the members will have what? Zero force members. So whenever you will see such type of system in a truss, you will say directly, sir, okay, both are what? A zero force system. Both are what? Zero force members, because no loading at this joint, no support reaction is acting at this joint. So both are zero force member. Very easy. Directly you can remember this point. Two members form a truss joint, both are non-collinear. Both are what? Non-collinear, right? So then both the members will become a zero force member. Okay, now see, next thing here, again, next concept here regarding this zero force member only, right? Regarding this zero force member. Okay, yes, Ankit, yeah, definitely will get this one. Okay, see, able to get form a truss joint, okay, which two members are what? Collinear. So whenever three members are there in which two are collinear, are you getting my point? Whenever three members join form a truss joint and two members are collinear, let's suppose this 1 and 2 and this is what? The 3. So obviously, see, try to understand this point. Obviously 1 and 2 are what? Collinear. See, try to focus here. 1 and 2 are what? Collinear. So whenever three members are there in a joint and two are collinear, third one will become what? Zero force member. This is the second concept. Only two concepts are required in front for calculation of the zero force member. 1 and 2 are there and 3 automatically will become zero force member. But ensure that 1 and 2 has to be what? Collinear. Then only the third member will become zero force member. Okay. But again, condition is same. No support reaction, no external loading. No support reaction, no external loading should be there at the joint. That is what the prerequisite for the validity of this particular condition. What is the requirement here? No support reaction, no external load, right? So I hope the concept is clear. Now directly we'll move on to the numerical. And I want everyone to answer this particular question. Find number of zero force member. Find number of zero force member in this particular truss. Okay, try everyone. Everyone, you should try. Okay, try this question, everyone. Find number of zero force member, right? Number of zero force member in this particular case. Okay, only two important conditions are there, right? When two non-collinear members form a truss joint, both will become a zero force. When three members and out of those three, two are collinear, then the third one becomes zero force member. Like that, two conditions are there. Now tell me the answer. Everyone tell me the answer for this one. Just the application of the concept just now we have discussed. Okay. Now see, if I observe this joint D, if I observe joint D, AD and DH are collinear member. At joint D, no support reaction, no external loading is there. So I can say DI member is a zero force member. Clear? Very easy. In a similar manner, A, E and EJ are collinear. Obviously, EI will become zero force member. Why? Because no load and no support reaction at E. Okay. Now, if I consider joint I, this is collinear, this is collinear. Both are collinear. HI and IJ both are collinear. AI will become what? A zero force member. Why? See, you will say, sir, DI and EI also there, but it obviously what? A zero force member here. Ankita has mentioned what? 7 here. Okay, we'll look that. See whether we'll get 7 or 6 or 5 or 8. So till now we have got what? 3. Again, in this case also, this are collinear, so it will become 0. This and this one collinear, so this one becomes 0, and also it will become 0 here. This is collinear, this is collinear. Now this will become 0. Simple. So 1, 2, 3, 4, 5, 6, 7. Yes, Ankit, your answer is correct. 7 is the correct answer here. So like that, you can answer this particular question, right? Zero force member, always remember, guys, always remember 2 important cases. 2 cases are there for the zero force member. 2 cases. Whenever 2 members form a truss joint and both are non-collinear, so both the members will become what? Zero force member. This is the case 1 we are having. What is the case 2? When a truss joint is formed by 3 members and out of which 2 are collinear and third one is non-collinear. So in that case, the force in the third member will be what? 0. So this is the case number 2. So only these 2 cases will help you in finding out the total number of zero force member. Got it? Now, I hope this is clear. Now moving on to the next numerical, again based on zero force member. Now this one is what? Very, very important one. Very important. Okay, and I want everyone to answer this one. Okay, I want everyone to answer. Okay. So this is what? A very important one. Okay. Right. Solve, everyone. Try to solve this one. See, this is 3 meter. This is 3 meter. This is 3 meter. In the question they have mentioned. This is force P we are having. This is force P we are having. Okay. Like this. In this case, what will be the zero force member? Tell me fast. What will be the zero force member in this particular case? Right. So this question is very important. Okay. Chances of mistake is high in this question. I'm telling you this, guys. Okay. Chances of mistakes will be what? High in this question. Now tell me what will be the answer here? What will be the answer? Just apply your basic concepts that we have discussed, right? What will be the number of zero force member here? What will be the zero force member? Okay. See, directly observing this particular truss, you will say, sir, this is a joint in which 2 members are there, which is what? Non-collinear, and no external load is there, no support direction is there. This one, there are this one and this one will become zero force member. Correct? Absolutely correct. 0, 0. So that is what immediately you can say. Okay, 2 members are what? Zero force member. That we have understood. Now, what about the next one? Either the 2 will be correct or 4 or 5 or 7. Which answer is correct in this case? Which answer is correct? Tell me, everyone. Which answer is correct in this case? Which answer is correct in this case? Tell me, everyone. See, apply the basic concepts. Initially, I've told you that this is what 0, this is what 0. 2 is the option, but 2 is not correct. BC, Ankit said BC is also 0. BC is also 0. Okay, got it. See, that is what correct point. See, if this is 0, obviously, if this member is horizontal, there is no one here to balance this BC. So, obviously, BC will become 0. Yes, absolutely. BC is also 0. So, now 3. But 3 is not the option here. But 3 is not the option. I lossy or lossless. 5 will be correct or 7 will be correct. Now, tell me everyone fast. BC correct? Yes. But what is the logic? See, if BC member has to be there, some member has to be there so that it can balance this BC force. So there is no one here which can balance BC. So automatically BC has to become 0. Correct. That logic is correct. But now what will be the total number of 0 force member? Everyone. So for let BC correct. Now see, if BC is 0, okay, this is 0, this is 0. Whatever support reaction is there, see, there has to be one support reaction here. Support reaction is there. Let's suppose we'll call it RC, and there is one support reaction here, RA. Okay, there is what a support reaction RA here. So if you just see what is the value of RC, can you calculate what is the value of RC here? See, if you will find a one amazing concept here, or important detail actually, not amazing, but that is what a very important thing that we'll find out here. Can we say CF also 0? CF. No, CF, see, CF will 0, it depends whether RC is 0 or not. See, this is not a very simple question, I would say. Okay, it looks like a simple, but actually more things are there in this question, which is what hidden. If we take point A, oh, that is what important point, Ankit. See, you are telling if we take moment about point A, what will have? Okay, obviously moment has to be what 0, but we'll see. P moment, this P will have what? P, what is the distance? 3 is there. Okay, that is correct. Anti-clockwise, this P will have a clockwise. Okay. What about this RC? RC will have this anti-clockwise. So RC into 9 distance will be there 0. But if you see from this one, P into 3 minus P into 3, it will be cancelled out. So RC value will become what? 0 here. Try to understand important point. RC value is coming out to be what? 0. RC value is coming out to be 0, then we can say CF is 0. Right? Because RC value is coming out to be 0. So this member will become 0 here. Are you getting the point? See, for understanding that whether CF is 0 or not, first of all, we have to evaluate what RC. And we are evaluating RC by taking moment about point A 0, we'll get what RC 0. If RC 0, CF member force will be what 0 again. Now focus on this joint. Only EF and this BF will be there. EF and BF will be there. Now see, to balance EF, there has to be what? One horizontal component. Okay, this one will provide the horizontal component. But to this balance this BF force on BF member, we need what? Vertical as well as horizontal. But in F joint, there is no vertical component. See, try to focus on this F1, right? Automatically this is 0, this is 0. Now focus on F. Okay, I will draw in the next page here. For joint F, I am drawing. Only these forces are there. So I will call it this by name EF and BF. Okay. EF and BF. Now try to understand. This is the joint F we are having. Now to balance this one, one horizontal force will be there. Okay, BF will provide. But to balance BF, we need what? Horizontal as well as vertical. But there is no vertical here. So obviously BF value will become what? 0. because there is no vertical force member, nothing is present in the vertical direction. No member is present or nothing is present in this vertical direction who can balance this BF vertical component. So no one can balance BF vertical component, so automatically BF will become what? 0 here. Okay, are you getting this point? So BF value will become 0 here, this value will become 0 here. Got it? So what will be the answer here? Now what will be the answer here? What will be the answer? Now tell me, okay, with the answer here. Everyone, the answer C will be the answer. No, 6 will not be the answer. C. See, let's suppose if I provide another option here, in that case, you will mark C. No, 6 is not the correct answer here. Why? Try to understand. See, when this is 0, this is 0. Now try to focus on this one. Okay, try to focus on this joint B. This 0, this 0. This P force will be balanced by this one. So, and this AB will be there and it will become what? 0 force member. Why? Because there is no one present in the horizontal direction which can balance the force in AB member. There is no one present in the horizontal direction which can what? Maintain what? Equilibrium with this AB. So AB also 0. Yes, Ankit, that is what correct here. AB is also 0. So how many 0 force members are there? 7. 7 0 force members are there, and option D is what correct here. Option D is the correct answer. So it looks what very simple, but it is not that simple, right? You have to apply all of your concepts, right? You have to apply all of your concepts. If you don't find out this RC, you will assume, okay, RC will be there definitely for sure. Okay, initially you will say, okay, in every value will be there, definitely for sure RC will be there. Okay, so if you don't find out the value of RC, you will not be in a position to calculate. This is, remember, this 0, this 0, you will not be able to calculate. So we have calculated this RC value and will get what? RC as 0. So that is what a very important point. If you don't know whether RC is 0 or not, will not be in a situation to tell the correct answer here. Are you getting? That is the important. So very, very important question. Okay. I hope this 0 force member concept is clear to everybody. Now, moving to this next article. Again, very important one. Very important. Specifically, see, in truss always follow method of section. That is what very, very important method and very easy to solve any gate question. You can solve any question in your gate examination with this method of section, right? So we'll be using method of section only. Will not use method of joint because it will eat up time. And in the gate specifically, we have to time management is required here. Okay, time management is required, and we have to solve question in a very less time. Okay, so that is what our strategy will follow, the quickest method. That is what method of section. In this question, they're asking what? They're asking, remember DF. So where is the DF? Okay, DF is there. So obviously we'll pass a section which is passing through this DF. Okay, we'll cut a section here. So let's suppose this is the section we are having. So this is the section we are having. DF will be like this. Now to solve this question, obviously, see, we have used this section. Two parts of this truss, two parts will be there, left side and right side. This truss will be divided into two parts, left or right. So when we are talking about equilibrium condition, each and every part of the truss will be what? In equilibrium condition only. Okay, so with the help of this section, we have created two parts here. Okay, we have divided the truss into two parts. So left and right, either you analyze left or right, you will get the same answer, and the both left and right will become in an equilibrium condition only. It will be in equilibrium condition. Okay, because we are designing our truss with respect to equilibrium conditions. Okay, because it is a structure. So very important concept. Both in mechanical and civil it will be there. In mechanical and civil, both they will have such kind of numericals. Okay, so try everyone. I need an answer for this one. Everyone should try the question. At least try this question. Using this section, you will cut the truss into two parts. Use the left or right. It's your choice. But we need the time, yeah? Okay. So if you use the left part, no, for that you need what? The support reactions. Better to use what? The right part. Because in that case, you don't need to calculate the support reactions. Okay. Just you have to apply your mind also, right? In some cases. Because if you go directly one by one, step 1, 2, 3, in that case you will take lot of time. So if you apply just common sense here, you will focus on the right part. Why? Because there is no need to calculate support reaction. But if you select the left portion, in that case you need what? Support reaction. So it will create one more step. It will take more time if you analyze the left part. Right? So section is cut. Now what will be the remaining portion? The right portion, right? Okay, we'll draw this one. See, try to observe this thing. Very important. Right? We'll draw that one, and simultaneously you should also draw these things. Okay, so see, so we have this one, 1 and 2. Okay, like this we are having. Okay, and what is there? Okay, like this, like this, like this. Okay, cut it here. Okay, no issue. So see, try to focus on this one. One triangle is there. Okay, then that is what triangle. So we'll focus on the right part. Okay. Sir, can we use two member or collinear? Then the third force will be what? 0. Yes, Sandeep. Yes, absolutely you can say, but there is one condition here. See, whenever a truss joint is there, see, try to focus on this point. See, whenever a joint is formed by 3 members, and out of 3, 2 are collinear. Okay, that is the concept. Whenever 3 members will form a truss joint, and out of which 2 are collinear, then third one will become automatically 0 force member. But what is the condition? No support reaction, no load will be acting at the joint. Right? Okay, I hope this is clear. Then yes, method of section only will use here. Method of joint will not touch, okay, because it will take lot of time. Method of section, with the help of method of section, this question will become a very, it will take what? Very few minutes. Hardly it will take 2 minutes. But if you solve through method of joint, it will take more than 5 minutes. Okay. So such numericals will be there. So always use method of sections. In my class, I have always told students, always use method of section. Okay, and keep practicing more and more truss numericals with the help of method of section only, right? So that is there. Now moving on to this part. So we have drawn this truss case here. Okay, so like that. So we'll draw here. Okay, so please keep solving this question and tell me the answer. What will be the answer here? Okay. And what is this point? Okay, we'll have to draw the one more line here. Okay. We have to draw this one more line here. No problem. We'll do one more line. Okay, like this we are having. Correct. I hope so. Now it is correct. Okay, now it is correct. Okay, correct. So this one, see what are the different cut members are there. This is what DF. Okay, this will have a DF, force in member DF. This is the one cut member. And what about the other cut members? CD is the one cut member. Force in CD is the next cut member. And what about other one? AC is the next force in member AC. This is what the cut member. So AC is the cut member, CD is the cut member, DF is the cut member. Okay. So I hope this is clear. Okay. DF is the cut member, CD is the cut member, AC is the cut member. Right? Ankit is getting what? 52. Okay. We'll see whether we are getting 52. And you're telling what? The compression. Okay. We'll see that one. So I hope the method of section is clear. AC is cut, CD is cut, DF is cut. Okay. So we have this triangle CEF. We'll mention the names here. CEF and what is there, CEF GIH, GIH, okay, and we'll make a dotted point here, right, like this. So in order to calculate force in member DF, okay, what we can do, we will take a moment, okay, we'll do what, we'll take a moment here, okay, we'll take a moment about point, about which point we should take, tell me, which point will be the correct point at which we can take the moment? Point C. Why we have chosen the point C? Because if you take the moment about point C, AC and CD force members will automatically become 0. Yes, Saurabh, will take a point C. Because if you select point C, then only you will get a moment of this force AC and CD will become 0. Only DF will be the unknown value. Only DF is the unknown value. That's why we have selected C. But to calculate moment at about point C, we need the perpendicular distance, right? What we'll do, very important point, okay, sometimes find a difficulty in calculating the perpendicular distance, don't worry, always use what, use the resolved components of the force. There is what, inclined force. So if I select this force, no, it will have a one component like this, it will have a one component like this, okay, this is force DF. So let's suppose this is alpha we are having, so this is what, force DF cos alpha, and this is what, force DF sin alpha, like this we are having, okay. So we'll remove this one because to have the clarity, okay. Okay, so this is what, now only DF cos alpha will be there, which is having a moment at about point C. DF sin alpha will not have a moment because it is passing through C only, it is passing through C, so it will not have the component, it will not have a moment here about which one, DF sin alpha, only so DF cos alpha will be there. Now our objective here is to find out this alpha value, okay. This is C, this point is what, D, we need distance CD also, okay. In order to write this equation, summation of moment about point C0, what we will do, DF, force DF cos alpha into distance CD, okay, it is having a what, clockwise moment, correct, okay, otherwise okay, some external loadings are also there, so C at C 10 kilonewton, E GH 10 kilonewton is there, okay, okay, 10 kilonewton, 10 kilonewton, 10 kilonewton, and distance is what, 3 3, that is what clear here. So 10 will have a clockwise, it will have a clockwise, it will have a clockwise, okay, no issue. DF is again also having clockwise, so 10 into 3 plus 10 into 6 plus 10 into what, 9 equals to 0. From this one we'll get the value of DF, but for getting the DF we first of all need to understand what is alpha here, okay. Just come on to this part and we'll calculate alpha. Come to this part and we'll calculate first of all alpha and CD value. See, alpha, basic mathematics you can apply here. See, that is what perpendicular, that is what base. 10 alpha you can write like this. Perpendicular is what, 5. What is base here? 3, 3, 3, 4 times 3, that is 12. 5 by 12. So from this one you will get the value of alpha very easily, right? Now, what is the important part? Okay, CD distance. Similar property, similar triangle property you can apply here to calculate the CD distance. So I can write CD divided by CI equals to AB divided by AI. So from this one CD will be equals to what, AB distance is what, 5. Okay, we'll have to remove this one. Yes, AB divided by AI. So AB is what, 5, AI is what, 12, that is 5 by 12. What is CI distance? That is what, 9. So from that one CD value we will get. So alpha is clear, CD is clear, right? Now you just need to put these values in this equation and finally you will get the answer. So I hope Ankita has got the correct answer, 52 kilonewton. Okay, 52 kilonewton is the correct answer here, right? So Ankit has got the correct answer here, 52 is the correct answer here, okay? So I hope all of you are clear with this type of concepts, and that is what very important, right? Okay, now moving on to the next part. friction. Okay, directly we'll come to the numericals on the friction, because again it is what very important. Friction and thrust are the one of the most important chapters in entire engineering mechanics, and you will see lot of questions they will be asking in friction. Last year also they have asked question from the friction chapter, both in mechanical and civil. In both the branches they have mentioned this answer, right? So we'll solve this question of following relation. Okay, first of all tell me, just try it again. This is what very basic, and from the next question will increase the level of the question, right? So first of all solve this question, and remember in entire mechanics, free body diagram is one of the most important part. If you have minimum free body diagram correctly, you will get the answer. The half is what done here when you draw correct free body diagram. If your free body diagram is wrong, then obviously you will get the wrong answer. So if you draw the free body diagram correctly, you will get the correct answer. So tell me the answer for this one. Everyone, please tell me the answer for this one. Okay, tell me. uh, can we also directly use cos alpha from triangle with sides 12 and 5? Yes, in the last problem you are telling now. Yes, see anyhow, see alpha value, CD distance, it's all about basic mathematics. You can use different ways also, different methods also to calculate those things. Yes, sin alpha value in expression you can write, right? In terms of, see, don't need to calculate. See, sometimes we'll do what? We'll calculate alpha, then we'll put sin alpha, then we'll calculate cos alpha. Better if the triangle dimensions are given to you, directly write sin alpha, directly write cos alpha expression. Okay. Okay. Akshadeep, yes, definitely we'll do in the fluid session. We'll do that, those things also. No problem. Okay, we'll do those things also, no problem. But here, just solve this question first of all. Try to solve this question, guys. See, first we'll do what? We'll draw the free body diagram. Okay, here only I will draw the free body diagram. Okay, and it will be what very easy for you to understand here. So that is what the block we are having. Okay, that is what the P force they are having. Okay, now see, W cos theta it will be there like this, W sin theta will be there. Okay, W cos theta, W sin theta, like this forces will be there. Okay, now that is the thing. Okay, what about this normal? Okay, this is the normal we are having. Symbol. We have mentioned effort required to impend up the motion. So whenever you are deciding the direction of friction, you need to understand the relative motion. So with respect to this inclined plane, the block is moving in the upward direction. So what this inclined plane will do, it will apply friction force in such a way so that it will oppose the relative tendency of motion of the block, right? That is there. So how it will be applying the friction force? Like this. Why we have applied friction force like this? Because it will oppose the relative tendency of motion. What is the relative tendency of motion of this block? Moving in the upward direction. Got it? That is there. So we'll apply this particular equilibrium equations. Okay, see, you can say you can consider this direction as what? X. You can consider this direction as what? Y. Okay, this is along the inclined plane X, perpendicular to the inclined plane Y. Directly do summation fx 0, summation fy 0, you will get the answer. What are the next steps that we need to apply here? Summation fx equals to 0, summation fy equals to 0. Right, that is the point. Okay, just apply and tell me which one of the options will be correct fast. Which one of the options will be correct here? Tell me, everyone. Which one of the options will be correct? Okay, which one of the options will be correct? right? We have drawn the free body diagram, right? Just we need to do what? Summation of forces along x direction we need to take, right? Now, if you take the forces along the x direction, what you will do? See, directly what you will do here, summation fx 0, right? And see, what are the forces? See, again, this angle is what? Theta, right? This is clear. So this is summation of forces along x direction. We'll write p cos theta minus w sin theta minus this frictional force equals to 0, like this. So p cos theta is there. You will have this w sin theta plus frictional force will be written as like this, mu n. So from summation fy 0 you will get the value of normal. From summation fy you will get the value of normal here. Okay, normal will be equals to what? Just try to understand what are the forces in normal direction, w cos theta and p sin theta. Don't forget about the p as well, right? W cos theta plus p sin theta. Okay, this is the value. Just you need to put this value in this equation and you will get the answer. Okay, see, by putting the value of n here, you will get what? W sin theta plus mu multiplied by w cos theta, right, plus p sin theta, like this you will have. Okay, now try to solve this one. P cos theta will take the minus mu p sin theta. Here you will take the w common. It will become sin theta plus mu cos theta. Just divide the whole equation with the p value, cos theta value. You will get what? See, you will have this 1 minus mu tan theta, like this. Here it will be what? Tan theta plus mu, like this. So finally you will get the value of p as what? W tan theta plus mu divided by 1 minus mu tan theta. I hope this particular thing is clear to everybody, and you can check the options. You can check the options, right? Okay. I hope this question is clear to everybody. You can see the options like this. Which one of the options will be correct? See, we'll see. 1 tan theta plus mu is there, divided by 1 minus mu tan theta. Okay, mu plus tan theta, 1 minus mu tan theta. So option B will be the correct. Option B will be the correct answer here. Okay. I hope this is clear to everybody, right? Okay. I hope this is clear. So that is what a very basic fundamental numerical. Now, moving on to the next one. Yes, this is one of the most important question, right? And you will have this question in your GATE examination definitely, for sure. Maybe this year, next year, maybe next to next year. Definitely such type of questions we have here, because this question has already been asked in some other paper. Okay. And it is what a very beautiful question. What they are asking, the range of value of f so that the block will remain in rest condition. You need to tell me the value of f so that this block will remain in rest condition. So they are asking not the value, they are asking the range. Okay, range, preserve the different range. Okay, different range they have mentioned. So what you need to do, you have to solve this question and tell me the range in which the block will remain in rest condition. Now, R to AB. What understand one important point, right? What closure of A? What two cases will be? Either the block will have a tendency to move in the upward direction. In that case also it will be in equilibrium. So I'm not saying it is moving. It will just about to move. Impending motion in the upward direction. What is the impending motion? When the motion will just about to happen. Motion will just about to occur. Okay, motion will just about to take place. Not there. Okay, but it will about to take place. That is what we are saying. So, impending up the plane, case number 1. Impending down the plane, case number 2. So both the cases you have to solve and tell me the value of f. So in the case 1 you will get the value of f. In the second case also you will get the value of f. And between that particular range, this block will remain in rest condition. That is the important point. Okay, I hope this is clear to everybody. Right? This is clear? Yes or no? So we'll solve this question. See, basic mechanics you can apply. If this is the F, obviously this is the F, and here what will be the value of force here? 2F. What will be the value of F here? 2F. Okay, value of F in the block acting will be twice, 2F will be there. Okay, so first of all I will draw the free body diagram here. Again, step number 1 is what? Draw the free body diagram. But case 1 I will take impend up the plane. Impend up the plane. Okay, I am considering the motion up the plane. So in that case, see, this is the block we are having. This is 2F. Okay, this will be what? W sine 30. This is W cos 30 we are having. Okay, so when it is upward, friction force will be acting in the downward direction. Okay, like this. This is the normal we are having, like this. Okay, clear? So only this forces will be right. You can easily calculate the value of 2F. Along the inclined plane I will take 2F minus this W sine 30 minus this frictional force equals to 0. So this equation comes from which part? Which equation I have applied here? Summation of forces along inclined plane. Along inclined plane, right? Along inclined plane I will take. So along inclined plane I will get the answer here. See, 2F will be equals to what? W sine 30. Sine 30 is what? 0.5. Frictional force value. Mu n. What is the n value here? N value will be what? See. N value will be what? W cos 30, right? Cos 30 value will be what? 0.86. Directly I will write 0.866 like this. So 0.866 will be this. Now see, try to understand. 10 kg. Okay, G value we have to take what? 10. Okay, so it's specifically when they have given G take as 10, then only in that case I will take. But in other cases I will take 9.81 as the value of G. Right, now try to understand. Okay, so 2F weight value will be what? 10 into 10 mg. Mu value, okay, we forget about the mu value. What is the mu value? 0.65. 0.65 into 10 into 10 into 0.86. So from this one you will get the value of F. So that value of F will be what? Please tell me what will be the value of F here. Fast, calculate it fast everyone. What is the value of F here? What is the value of F here? Calculate everyone. Because that is what required here. Okay. And without that value, will not be able to solve this question. Okay. You have to tell me the value of F here. See, sometimes what in this, see, you solve the question, but while solving question, you will do what? Silly calculation mistakes. Okay. You have to be what? Very careful about writing the steps, writing what? Doing calculations. That is what very important part. Otherwise, you will make mistakes. Okay. So from that one you will get the value of F. So case 1 we have taken impend up the plane, right? To calculate the range we'll take second case as what? Impend down the plane, right? Case number 2 will take impend down the plane. Impend down the plane, right? In that case the direction of friction will change. See, everything will remain same, just the direction of friction will change. W sine 30 again same. W cos 30. Okay. This is the normal. But in this case, when it is moving down the plane, frictional force will change the direction. Okay, because frictional force is what offers or see, it will always opposes the direction, or it will always see, provides the resistance against the relative tendency of motion. It will oppose the relative tendency of motion always. That is the point that we need to understand. Okay, so this is the point when it is impend down the plane. So if I write the equation here, see, equation what? Which equation we have to write? Summation of forces along the inclined plane. Along the inclined plane will take, right? So that is the important equation we have to apply. So see, after applying this equation, see, 2F minus W sine 30, right, plus frictional force mu n equals to 0. So 2F value, you will see what, W sine 30 minus this mu n. So see what value you will get. Mu value is 0.65, n value is W cos 30. After solving this value, see what answer you will get. What answer you will see, in this case, see, if you solve the first case one, no, you will get this answer. You will get this 53.15 Newton. But if you solve the second case, you will get the answer in negative. But we are getting answer negative. What does it mean? What does it mean? We are getting the answer in negative. Actually, there is no requirement of the force to have this block in a static condition. We don't need to apply any kind of force so that it will remain in static condition. Why? Because see, what will happen? The friction force will anyhow, it will take care of this force W sine 30. See, who will create the tendency of motion here? W sine 30 will create the tendency of motion, and the friction force will take care of this thing. So when the friction force is capable of taking this thing, okay, when the friction force is capable of taking this thing, so obviously it will remain in what? Static condition. There is no requirement of application of this force. Are you getting my point? Right? There is no requirement of applying the force F so that it will be in a static condition. So in the second case, we are getting answer as what? 0. We'll take answer as 0 in the second case. So finally, what is the range for which the block will be in static condition? 0 to 53.15 Newton. So for that range, the block will be in static condition. So which option will be what correct here? C will be the correct answer. Option C will be the correct answer. Are you getting the point? Okay. So that is what very okay. Now again, see, this friction is what a very important topic for the GATE examination, and most importantly, it is the conceptual part. Directly formula, just memorizing the formula will not help you, right? You need to understand some concepts, and see, you need to practice some numericals also. Only then you will be able to solve questions, right? Now again, this question looks what very simple, but that is what not an actual scenario here. You have to apply your basic concept, otherwise you will get a wrong answer, specifically in friction chapter. If the basics are not clear, you will get the wrong answer. You will feel, okay, question is what very easy, I can solve directly by using this formula. You will get the wrong answer, right? So just try this question, everyone, and tell me the answer. Okay, just tell me the answer for this question also. So they are asking what the smallest P that must be applied to 150 Newton block in order to cause the block to move, right? They didn't mention about the sliding, they didn't mention about tipping. Okay, one by one I will consider the cases. One by one I will consider the cases, and after that I will decide whether tipping will be there or sliding will be there, right? Only after both analysis I will be in a position to tell that sliding will be there or tipping is there or sliding is there. Here we are getting. So after the analysis I will be in a position. Okay, so this is the block we are having. So see, I hope concept is clear. No, now you will find. See what I will do here. First of all, I will assume sliding. If I assume assuming sliding motion, first I will assume sliding. So if sliding is there, obviously, see, summation of forces along horizontal direction 0 I will take, tends to I will take, no. So frictional force will be acting here. Some normal will be acting like this. Some normal will be there. Okay. So P value will be equals to frictional force, and if you apply summation of vertical forces, you will get what? N value as 150 Newton. Very simple. And P value will be what? Mu n. For mu value 0.5 they have given. 0.5 into 150. And if you do like this, you will get what? 75 Newton. And you will say, sir, 75 Newton is the correct answer so that it can move. But that is not the correct answer here. It is what? Wrong. Okay, now you need to understand why it is wrong. Okay, directly assume the sliding case, we will get 75. No, 75 is not the correct answer, because they are asking the smallest force, P, that will create a motion. They didn't talk about sliding that we have assumed in the first case. Are you getting my point? Right. That is the point we need to understand. Very, very important case. Okay. Now see what will happen. See, if there is a tipping case, right? So let's suppose I will show the friction force in different color. That is what the normal we are having. Okay. Assuming this is the center of a body, C. Okay. From the center, it is having a distance x. Okay, like this. So assuming a tipping case. Okay. Now sliding is there. Okay, got it. Now if there is a sliding, the normal has to be what? Within this base. Normal has to be within this base. If normal is lying outside this base, a tipping will be there. Okay, so you have assumed the sliding. Now you need to what? Verify whether sliding will take place or not. Regarding the point, whether sliding will take place or not, that we need to decide. How we can decide? How we can verify that concept? Okay, just ensure that normal has to be what? Within this base. If it is lying outside the base, tipping will be there. Now we'll check whether normal is lying within this base or not. Okay, for that what we'll do, we'll take one thing here. Okay, we'll do one thing. See, assume this point as A, assume this point as B. So moment equilibrium you can take at any point. You can take the moment equilibrium. Okay, it's your choice. Okay, but if you use the basic common sense, no, you will take the moment about that point where the number of moments because of the forces will become 0. Less calculation will be there. Okay, select though that particular point at which the calculation will be what? Less. You can take any point. You can take the center of a body as well. You can take point A, you can take point B. It's your choice. But select that point at which, if you take the moment values, calculation of moment you will do at that point, calculation will become what? Very easy. So accordingly, if I apply the common sense, I will select one point here. Which point I will select? I will select this point. Let's suppose this is the point, I will call it as what? X. This is the point X. Point X is what? The point at which the normal and the friction is there. Okay, at which normal is acting. I am assuming normal is acting at point X. So I will calculate the moment about X. Why I am calculating the moment about X? Because friction moment, normal moment will become 0. Okay, you can calculate moment about point C as well. But in that case, friction moment will be there, normal moment will be there, P moment will be there. 3 forces we need to take. But if I take here, only P force and this weight I have to take care. Only 2 things I have to take care. Right, that's why I have taken this value X. It's your choice. Okay, it's totally your choice. Okay, and you have to use the common sense also. Always try to reduce the calculation part. Okay, always take some moment and just apply your common sense and see in which way I will be having the less calculation. So just go with that way only. Okay, just go with that way. Right, so this is the point. I hope this is clear. So next thing what I will do, I will take the moment about point x0. Right, about point x I will take the moment 0. So only this weight will be there, W and P. So because of W clockwise, because of P anti-clockwise, right? So W into x will be there and anti-clockwise P into what is the distance we are having? 3 meter. Okay. So from here I will get the value of x. P value, obviously sliding value we have to take. What is the P value? 75 Newton. 75 into 3, what is the weight? 150. Now after solving you will get the value of 1.5 meter. Now see, if x value is 1.5, whether normal is lying within this base AB or not, that you need to decide. Are you getting the this normal will lie outside the base. Obviously this normal will lie outside the base, and it means what? Tipping will be there before the sliding. Tipping will be there before sliding. Okay, always remember this point. Very, very important. When you have assumed sliding, you need to verify, you need to check whether actually sliding will take place or not. Are you getting the point? For that you need to ensure whether this normal is within this base or not. If it is within the base, obviously sliding will be there. But if it is getting outside, if it is not within the base or it is lying outside the base AB, tipping will be there for sure. Tipping will be there. Got it? That is the point we need to understand. So what we have understood from case, okay, we'll write here outside AB. So from this I can say what? Tipping will be there. Okay, tipping will be there. So in order to calculate the tipping value, see, in order to calculate tipping value, do a limiting case. You will assume about point A, you will take the normal and you will calculate this value of AB here. Okay. Just a minute. Here only I will solve. Okay. Or we'll take the next page. No issue. See, again I will draw this block first of all. Right. Now, that is what the P force we are having. At this point, see, the friction force. See, why I have chosen this corner? Can you tell me this point? Because we are talking about the limiting case. We are talking about this limiting case. So that's why in the limiting case, always normal will be at the corner. Okay. So that is the point we need to understand. So this is the block, this is the normal, this is the friction force value, and this is the value of P we are having. Okay. Now try to understand this point. Very, very important. So I will take the moment about that is the point A we have assumed. This is B. We'll take the moment about point A equals to 0. So P into distance 3 and this W into distance what? I think it is what? 1. So P will be what? 150 divided by 3. You will get the P value as 50. So 50 Newton is the smallest force which will cause the motion in this case. Okay. I hope the question is clear to everybody. Very, very important thing. Okay. Don't directly just memorize the formula. You need to apply your basic common sense also. You need to apply the concept. You need to analyze the situation. After that, you can decide, okay, this formula will be applicable. So what we'll do in generally, we'll directly apply the formula because we have memorized the formula. So directly whenever question comes, we'll directly apply the formula. Just before applying the formula, just check whether that particular formula is applicable or not. If it is not applicable, then how you can apply those formulas? Are you getting the things? So that is what very, very important. Okay. Now, moving to the next numerical part. Yes, again, this is one of the most important question, guys. Very, very important, I would say. And see, chances are there, you will find such question in your GATE examination. Okay, yes, you will find such questions in your GATE examination because it needs what? Concepts. If you are good at the concepts, or the basic parts of the friction, clear with how the friction will work, how the friction will act, in which direction it will act, what is sliding case, what is slipping case, only in that case only you will be able to solve the question. Otherwise you will not be able to solve. Such as you will have, okay, simple questions you will not get in the GATE examinations. Obviously some advanced questions you will also get. So that is what we are doing here. We'll do what? See, why we are doing this GATE booster sessions, right? So that you will be in a touch, okay, you will be having what? A feeling, so that you can solve this advanced level question also. Because most of the time you are solving PYQ. You need a touch of advanced level question also. You need to practice those questions also. Different variety of questions, right? Just practicing same thing again and again will not help you. Okay, you have to practice some different things also. Okay, to be on the topper list, okay, you need to apply, you have to work differently. Okay, if you want high marks, okay, you need, okay, what do you want? High marks, good score you want, top score you want. Obviously you need to do things differently. Okay, you have to do some different task also. Okay, altogether you have to work differently, right? You will not go as the huge mass is doing. Okay, you have to work differently. That is what required here. So try to solve this question, very important one. Okay, so just first of all, before solving question, read the question carefully. That is what required. A body of dimension as shown in figure must be pushed up the inclined plane. Okay, so from the question language it is clear, it is moving up the plane. That is what required. First of all, we need to understand where it is moving. what must be the maximum height at which force P should be applied parallel to the incline so as to cause it to slide without tipping over. Okay, we need the sliding without tipping over. Take the coefficient of friction as 0.2. Now try to solve this one and tell me the answer. Everyone please try this one and tell me the answer. Right, tell me the answer everyone. What will be the answer here? Okay, now see, they've mentioned sliding case without tipping over. Okay, we need to ensure tipping has not been there. Okay, tipping has not be the part of this question. Okay, tipping has not be there. So we want to ensure tipping has not, okay, tipping should not be there in this case. So we need to ensure those things also, because specifically they have mentioned sliding should be there without tipping. So tipping has not been there. We have to remove this tipping case. Okay, how we can remove? Actually, we need to analyze this particular situation with tipping also and see in which case, under what criteria tipping will not be there. That is, we need to understand. Okay, now okay, see for the case of sliding, see what will happen. So they are asking the maximum height. Okay, so again the limiting case you need to apply. Limiting case. Okay, limiting case we need to apply. So in the limiting case, see what will happen. A normal will be like this. Friction force will be like this. Okay, now try to understand. This is the weight. Okay, component of a weight will be like this. W sin 30. W cos 30. Okay, like this. I say T. W cos 30, W sin 30. Like this, it will be resolution of the force, weight. Now, normal and friction force I have assumed here. Why? Because I want to calculate for the limiting case. For the limiting case, it will be here. Okay, because if it is move outside the base of this block, then there will be tipping. So actually in the question they have mentioned maximum height. So for the limiting case, we will get the maximum height, right? But if goes beyond this one, so if this normal shift here, so obviously tipping will be there. So at this point tipping will occur. So normally what you have to do, you have to place this normal, you have to shift this normal to this corner point. So first of all, try to understand, try to identify about which corner tipping will be there. Because of the application of this force, tipping will be only. What is the simplest shift? The you have to simple. Now what we'll do, we'll take a moment. I will call this point as A. I will take simply what you have to do, take the moment about point A as 0. Simple. So what will be the moment? Because of the P, because of P will, there is one moment here, P multiplied by H. Okay, it is having a clockwise moment. This W cos 30 will have an anti-clockwise moment. W cos 30 multiplied by which distance? Half of 50, that is 25. This W sin theta is also having anti-clockwise moment. W sin 30 into what is the distance? 75 by 2. 75 by 2. Okay, and equate it to 0, you will get the answer. But now after writing this equation, most of the students will be having a confusion. Sir, there is no value of P. How I can solve this equation? There is two unknown. P is the unknown, H is the unknown. H is the unknown that we need to find out, and P is not given. How we can find out P? This value of H? Simple. See, they have mentioned what? Sliding has to be there. Without tipping, we have to ensure we have to ensure what? Tipping should not occur. Tipping should not occur. So in that case, P value has to be what? See, now try to understand this point here. For sliding, P value has to be what? Greater than, okay, greater than or equal to the resistance that is what offered by this block as well as this friction. What is that value? W sin 30 plus this frictional force. Okay, so if P value is greater than this one, then the sliding will be there. So obviously for sliding, this value has to be what? The value of P has to be what? Greater than. But in the limiting case, I will take equal mu into n. I will take in place of mu. I hope you understood that. What is the value of n here? Mu value they have given 0.2. Normal value is what? W cos 30. Right. So P value is here. So from this P value, if you put P value here, you will get the value of H also. So that is what the equation number 1. This is equation number 2 here. So in the next page from equation 1 and 2, you will get the value of H. Okay, just you need to put the value of P. Just you need to put the value of P here, you will get the value of H. Is this point clear, everyone? Is this point clear? So just you need to put the value of P here and you will get the answer. Okay, so again I will put the value of P here also so that it will be what clear to you. So better will put the value of P here. Okay, so if you see what is the value of P here, W sin 30 plus friction force mu into n, that is W cos 30 into H. Okay, that is the value of P we have taken, and remaining equation, see all this negative sign will go towards the right side. Okay, so it will be like this, W cos 30 into 25, right, plus W sin 30 into 75, half of 75, that is 75 divided by 2. From this you will get the answer. From this you will get the answer of H. Will get the value of H here. Okay, and if you solve, it will come out to be around 60 centimeter. Okay, that is what the answer here. So I hope question is clear to you, and this is one of the most important question for the friction chapter. One of the most important questions from the friction chapter, right? Tell me, is this part is clear, everyone? Yes. Okay. So they've mentioned in the question, sliding has to be there without any tipping. Tipping, we have to ensure what? Tipping should not be there. So tipping should not be there. We have to consider what things? We have to consider only sliding case, right? How we can consider those things? Now see, we have taken the limiting case. Why we have taken moment about point A 0? Just to ensure limiting has not been there. Okay, because this is the point up to which tipping will not be there. This is the point up to which the tipping will not be there. Okay, see, generally our normal will be like this, but normal will shift here as the force P is increased. Okay, as the P force is increased, and it will try to rotate. It will try to tip about point A. So when the block tipping is there, normal will have a tendency to shift in this condition. So up to this point, if the normal is there, tipping will not be there. But when normal shifts outside this base, okay, outside this base, then obviously tipping will be there. So generally when the tipping is about to happen, the normal shift to the corner, shift to that particular corner about which tipping will be there. Okay, tipping will take place about point A. So for the limiting case, what is the limiting case? When the tipping is just about to happen, in that case normal shift to that particular corner at which tipping will be there. I hope this is clear to everybody, right? So always remember these things, very, very important. Right? So one of the important questions from the friction chapter. Now, again, see, lot of times in the GATE examination, they have asked questions from this centroid moment of inertia. But I hope this is what a very simple topic for you. Again, very simple mathematics, simple steps you need to follow. there is no such difficult questions you will find in this trick. Just you need to ensure what the calculation has to be what correct. If the calculation is not correct, then obviously you will get the wrong answer, and you have to follow some basic steps, and you will get the correct answer. Okay, so we'll see some question from this one also. Right, this is one of the question. This is one of the question. You need to find out the centroid of this particular system. You need to find out the centroid of this particular system, right? You so calculate, everyone. See, in a quadrant, a semicircle is there. Okay, a quadrant which is having a radius r, and a quadrant, in this quadrant a semicircle is there for which radius is r by 2. Okay, first of all you need to understand these things, very important. For this semicircle, radius will be what? R by 2. Okay, so in the quadrant a semicircle has been cut. Okay, what is the shaded part they are talking about? This is the shaded part. This is the shaded part they are talking about. So for this shaded part, they are asking what? The centroid. They are asking the centroid. Is this clear? So for this shaded part, they are asking the centroid part. Now, okay, we'll solve this one, everyone. Okay, so for the quadrant, first of all, try to understand. See, always remember, two cases, two parts will be there. First, I will consider the whole quadrant. Okay, first part will represent the what? Quadrant, and the second thing will represent what? The semicircle. I hope you are getting the point, right? First part represent the quadrant and the second part represents semicircle. In the quadrant, semicircle has been what? Removed. Whatever the remaining shaded part is there, for that we need to find out centroid. Okay, and so first of all I will calculate this x bar. See, dimension reference system they have mentioned. With respect to this reference system, we need to calculate the centroid as well as centroid of this x bar and y bar. Both in x, y direction we need to calculate centroid, location of a centroid actually. Reference system they have given. Okay, so considering that reference system only, I will calculate x bar. So see how I will be able to calculate this reference, this particular thing. First part is what? The quadrant. For the quadrant, what will be the area? Pi r square by what? 4. That is what the area of a quadrant. 1 by 4, 1/4 of the circle area. Radius of a quadrant is what? R only, right? Into what is the location of centroid for quadrant? I hope you remember this basic things. For quadrant, centroid will lie here. Both in x, y direction, you will have this thing 4r upon 3 pi. 4r upon 3 pi. I hope this is the basic thing you need to understand. Okay, 4r upon 3 pi. That is what correct. Plus, what is the second area? Semicircle, but it has been curved, so we'll remove. We'll put what? Negative sign here with the area. Pi into r square by 2. But here r is what? R by 2. Okay, that is what the area we are having. Into what is the distance? What is the distance here? Okay, the basically the centroid of the semicircle. Centroid of a semicircle will be what again? See, try to understand this point. Here I will draw. If you see, this is the semicircle, no? This distance again become 4r upon 3 pi. Right? Again 4r upon 3 pi, but r is what? The r radius of a semicircle, right? R is the radius of the semicircle. You have to need to take the radius of semicircle here. Okay. So again 4r upon 3 pi. What is r here for the semicircle? R by 2. 4r upon 3 pi. Here in the denominator part, what you have to do? Take the areas. Pi r square by 4 minus pi r by 2 square by 2. So from this one, you will be in the position to calculate the x bar. Okay, and I hope this is what very simple for you to calculate the x bar. In a similar manner, you can also calculate y bar also, right? So quickly solve y bar also. Okay, so just remember these points, very important. Okay, I will mention some important cases here. So if this is a semicircle, so this will be the centroid, but for location of this centroid will be what? Like this, 4r upon 3 pi. Okay. If the quadrant is there, if quadrant is there for this one, for both the sides, okay, x and y, 4r upon 3 pi. Okay, that is two things you need to remember, because these two things are required to solve this question, right? So x bar we have written, x bar we have written. Now next write down the y bar also. Next write down the y bar also. How we can write the y bar? See, again area, obviously area will remain same, pi r square by 4 into y. In case of coordinate x bar and y bar are same, you will write directly 4r upon 3 pi minus pi r by 2 square by 2 semicircle area into, but in the case of semicircle, the y bar will be here, so it will be what? R by 2. It will be what? R by 2. And in the denominator you will have the areas only. Like this. So y bar, you can get the answer here. Okay, so just solve both x bar and y bar, you will get the answer. Solving this x bar and y bar, you will be getting the answer here. Okay, so everyone please solve and tell me the answer for x bar and the y bar. See, calculation plays a very important role in engineering mechanics and any subject of engineering, right? Because just only knowing the concept, just knowing the formula, it will not guarantee that you will get the correct answer. Correct answer will depend upon lot of number of factors, whether you know the formula, whether you know the concept correctly, whether you have used the correct relation, whether you have put the values in the formula correctly or not, whether you have used the SI unit or CGS units properly or not. Okay, in some cases they will give the units in a CGS, but in the formula we need to put the values in SI terms. So you need to convert what? CGS into SI, then only you will put those values in the formula, right? So that is what a lot of factors are there. Calculation mistakes should not be there. So lot of factors are there. Just remembering the formula will not help you. Okay, so you need to practice lot of questions, because see, in the gate examination what is required? The confidence, and the confidence will come when you solve multiple number of questions of different level, right? If you solve only one level of questions only, you will not be in a position to solve next level, higher level questions. So always ready to solve some higher level questions also, advanced level questions also, because in the gate definitely they will give some advanced level questions. So that is why we are having this gate booster series for you, so that you can have a different variety of questions as well, and you will have the feeling just before the gate examinations, right? So tell me the answer, final answer. What will be the final answer you will have? Tell me what is the final answers you will have. Okay, so after solving this one, see, I will write the answer here for you, just for your reference. See, finally you will have this value of x bar 0.637r and y bar 0.349r. Okay, so option A will be the correct answer. This option, the first option will be what? The correct answer here. Okay, so option A will be the what? The correct answer here, right? So that is what the question we are having. Next, moving on to the next part. Next question is from the moment of inertia, right? Solve everyone fast. Again, very basic question, but be careful while writing the moment of inertia. But lot of time now what happens, students do what mistakes in calculating this moment of inertia values. Okay, so just try everyone and tell me the answer for this one. Everyone please try and tell me the answer.
Tell
me the answer, everyone. So you need to calculate the moment of inertia about x-axis. Okay. So whenever you want to calculate the moment of inertia, just try to understand where, about which axis they are wanting the answer. Okay. About which axis they asking. Okay. About which axis they are asking the moment of inertia value. Okay. Because see, whenever we want to calculate moment of inertia, we need to know about which axis we want to calculate. The axis is not clear, or let's suppose if you take the wrong axis, you will get the wrong answer. Simple. See, in this case they are asking for this x-axis, this x-axis, right? I hope this is clear. So see, first part is what the, again, quadrant is there in a semicircle is there. Okay, first I will take the total moment of inertia of the quadrant and I will subtract the moment of inertia of this semicircle. See, easily I can do both semicircle and this quadrant will have this common axis. Okay, both will have a common axis. So easily I can do here. So, but before solving this one, you need to understand two important concepts here. Okay. Okay, for this circle, xx and yy, what is the moment of inertia value? Okay, about xx, about yy, pi by 64 into d to the power 4. Pi by 64 into d to the power 4. Very basic formula. But if I want to calculate the moment of inertia of a semicircle, which is like this one, let's suppose if I cut this circle into two parts, this is a semicircle. So about this xx axis only, what will be the moment of inertia value? Half of this one. Half of this one. Let's suppose if I take one more half, if I make this semicircle into quadrant, what will happen? Again, for this axis, xx, what will be the moment of inertia? 1 by 4 of pi by 64 into d to the power 4. Like this it will happen. Are you getting the idea? See, again, for the circle, this x axis
here, that is also we have taken.
Not for semicircle, but not for this quadrant. X axis for this semicircle and x axis for this quadrant are not centroidal axis. What is the centroidal axis? For the circle it is taken. For this one and this one, it's not centroidal axis. Centroidal axis will be what? Here only, right? Where it will be? Just a minute, I will show you. Here it will be. The axis which is passing through the centroid, it will be known as what? Centroidal axis. So distance from here to here, it is what? 4r upon 3 pi. That we have already discussed. For this case, the centroidal axis will be this one. The axis which is passing through the centroid, like this. Like this. So this is the centroid part. So red one are the centroidal axis, not this xx. Okay. I hope the concept is clear. Now moving on to this particular numerical. Simple. What you have to do? Take the difference of the moment of inertia only, right? So we'll solve this question here. See how we'll solve. So moment of inertia about xx will be what? For the quadrant, we'll take 1 by 4 pi by 64. Okay, what will be the diameter for the quadrant? 2a. Okay. This is the moment of inertia for the quadrant. From this moment of inertia value of the quadrant, we need to subtract what? We need to subtract the semicircle one. See, we need to subtract the semicircle one, no, right? So we'll subtract this one, right? What will happen? For the semicircle, it will be what? Just half of the total moment of inertia, pi by 64. But for the semicircle, what will be the diameter? A only, right? A to the power 4. So just you need to take the difference and you will have the answer. Just you need to take the difference and you will have the answer. Okay. Thank you so much, Vipin. So for this one, just take the difference and tell me what will be the answer. Okay. But always remember, try to see what will happen. No, generally, if such a geometry will be given, I will do mistakes in writing the diameter. In such cases, I will do the mistake in writing this diameter. Diameter is for this quadrant will be diameter 2a. What will be the diameter for this quadrant? 2a. For this semicircle, what is the diameter? A only. Okay, so that's why I have written 2a here. That's why I have written a here. So this is the moment of inertia for the quadrant and that is the moment of inertia for the semicircle. Just take the difference and you will get the answer. Are you getting the point? So that is what very important. Okay, sometimes we will usually do mistakes in writing the correct diameter. Sometimes they have given radius and we have taken the diameter. Sometimes diameter is given and we have taken it as a radius. So that's why mistakes will be there. Okay, and we need to improve in that section. See, we have to minimize our mistakes so that our marks will be what maximized. Even if you know, even if you have practiced lot of things, but if you do regularly do mistakes, if you do mistakes in your GATE examinations, obviously even if you know the concepts very well, in that scenario also you will get the less marks because you didn't do what minimization of the mistakes. You didn't do those things, right? So how you those things? Simply you have to attend the AMTS mock test series. After giving mock test, you will be what in a position to analyze where actually you are doing mistakes, in which subjects you are not in a position to solve numericals. Okay, analysis will be there. See, test series are acting as a feedback mechanism to you. Before directly giving the GATE examination, actual GATE examination, feedback will be given by the test series. So always take the test series very seriously because it will give you a proper feedback. And based on that feedback, you will do improvements. You will try to put more efforts. Okay, you will try to reduce your mistakes. And obviously, because of doing like this, such things, you will have what maximize your score. You will do what maximize your scores, right? Okay. So if you solve this one, see 2 to the power 4 will become what? 16. So it will be what? 4 here. Okay. So pi by 64, a to the power 4 here, and a 4 will come here. Okay. And in this case, it will be what like this? 1 by 2 pi by 64 into a to the power 4. Okay. If I take the LCM, in the denominator 2 into 64, it will become 128. It will become 128, right? And 2 to 8. Finally, you will get what? 7 by 128 pi a to the power 4. And we'll see whether any option is matching or not. Yes, option number B. Option number B is what matching here. So that is what we got the correct answer here. Okay. So I hope you got the idea how to solve such type of moment of inertia numericals. Moment of inertia numericals are what very easy. If you solve PYQ, then it is what more than sufficient only. Okay, but you need to take care about this chapter like friction, like equilibrium, like thrust. These chapters are what very important. Okay, so I hope some things we have already covered. The last topic for today's session will be about the vibration, which is only for the civil engineering. Anyhow, this vibration topic is there for mechanical in another subject, that is what theory of machine. We'll take those theory of machine session in December. Okay, that will be there, but for today's session the vibration topic will discuss only with respect to civil engineering student, because only small topic is there in civil engineering, right? But in mechanical a lot of huge syllabus is there for the mechanical people, specifically from vibration topic. Okay, we'll move on to the next part, that is what the vibration, right? See, before moving forward, you need to understand which topic is there in our syllabus for civil engineering students, right? Topic is what? Vibration, but specifically if I expand this topic vibration, this is the part: free vibration, undamped, single degree of freedom system. Okay, we need to understand this heading before going into details. Before going into the details of this vibration, we need to understand this heading first of all. What is free vibration? What is free in this case? See, why they are calling free? What kind of thing like free vibration? See, those vibration in which there is no external force or no external agent is present, right? Only that particular scenarios or that particular situation will come under this free vibration. No external force is there in the free vibration case. No external force. Okay, no external force is there. Okay, it is what? Freely vibrating. The system is vibrating on its own. Okay, initially you have disturbed the system and after that the vibration has been set up and it is continuously vibrating, oscillating. There is no involvement of the external force. That point we need to understand here. Okay, so what do you mean by undamped? See, if the vibration is there, oscillation is there. What is vibration and oscillation? A repetition of motion. Like for this example, if if I displace this mass, what will happen? A vibration will set up like this. A vibration will set up like this. So if there is a mechanism or if there is any device which will offer resistance to vibration, or simply if I say resistance to vibration is known as what? Damping. And opposite to damping will be what? Undamping, undamped. If damping is provided, I will say damped system. In some cases, in some systems, if damping is provided, it is known as damped system. If damping is not provided, undamped system. Simply I will call it undamped system, right? So first of all, you need to understand what is damping. Damping basically means resistance to vibration. Resistance to vibration, right? Resistance to vibration is there. And undamped system basically means no damping is provided in the system. No damping is provided in the system. Okay, and what do you mean by single degree of freedom? It means degree of freedom is what? 1 here. So this is the complete meaning of the definition or complete meaning of the topic here, right? So free vibration of undamped single degree of freedom system. So no damping is provided, no external force is there. Simply the system is vibrating on its own. Initially we have displaced the system, that's why it is what? Getting vibration is set up in the system. Like this example, if I displace this mass, what will happen? Vibration will set up. Okay, so after initial disturbance, it will vibrate on its own. Okay, there is no involvement of external force. Okay, there is no requirement of any external force so that it will vibrate. No, it is not like that. It will vibrate on its own. Yes, obviously some initial disturbance is there, but no external force is present when it is vibrating. Are you getting the point? That is what very, very, very important in this case. So I hope that basic terminologies are clear. Now we'll discuss what are the important things that we need to understand. And directly from this, see, when this topic is introduced, in that year also 2 questions has been asked. In the next year also 2 questions they have asked. So definitely they will be asking a question from this one for civil engineering, because they have specifically added this topic. Why? Because it is what very important, right? It is what very important with respect to when you do analysis of structure. No, it is what very, very important topic. If you know a famous, actually I will say a famous bridge failure is there, Tacoma bridge failure, because of the vibration only, right? Because at that time they didn't consider this vibration concept. Okay, what happened? Wind is there, because of the wind load, a vibration has been set up in the bridge and it was collapsed after few months of its operation, right? That is what a very basic thing, important case study also that most of the civil engineers will study. Okay, so in the structure analysis, this vibration plays a very, very important role. We cannot neglect this vibration thing. Okay, so that is what they have added into the syllabus part. So which important things we need to understand from this gate point of view, I will discuss here. Okay, I will discuss. So see, point number 1 that we need to understand. Simple case they will be asking. So let's suppose this is the spring. So this is the mass M. Okay, now initially I have assumed there is no what deformation in the spring, right? So let's suppose if I hold this mass, obviously the spring is not what in a stretched condition. There is no deformation in the spring. I will call this spring as undeformed spring. Okay, now but if I remove this mass, obviously some static deflection will be there. Some static deflection will be there, and at that point it will be in a static equilibrium condition, right? It will be in a static equilibrium condition. Okay, so try to understand this point very carefully. From this one you will have the understanding of the concept. Okay, so like that, this is what under static equilibrium condition. Now what will happen in this condition? Obviously downward force is what? Mg. The spring force will be what? K into deflection, that is what? Delta. So this relation will be valid here. Now if I what do initial displacement, if I provide some initial displacement here like x here, Because of this displacement, some velocity will be there, x dot, some acceleration will be there, x double dot. Okay, so displacement will be there, corresponding velocity will be there, corresponding acceleration will be there. Okay, I am displacing the mass from a static equilibrium condition. Always remember this point, very very important. You will disturb the system from its equilibrium, static equilibrium condition. Okay, we are disturbing the system. See how we will get the natural vibration if you disturb the system from its static equilibrium condition. So from a static equilibrium condition, I have displaced the mass with x displacement, corresponding velocity x dot, corresponding acceleration x double dot. Like that we'll get the different values. Now if you analyze this block, okay, if you analyze this block, you will have this. If you analyze this block, what kind of forces it will have? mg, k, delta plus x. Delta is already the deflection in the spring, and additionally x displacement is also there. K delta plus x is there. After solving this one or applying Newton's second law, you will have this equation. Okay, you will have this equation like this. X double dot plus omega n square into x equals to 0. So from here omega n will be, you will have like this, k by m, under root k by m. Actually this equation, the simplified format is what, mx double dot km equals to 0. So that is what the equation we are getting after analysis. Omega n is the under root k by m, natural frequency we are having. Okay, this is the natural frequency we are having, and it is having a unit of radian per second, right? So now that is what the important point. Next, see, so point A we are having omega n, natural frequency, under root k by m, radian per second. Let's suppose if I want the frequency in hertz, what I will do? Omega n by 2 pi. That is what? 1 upon 2 pi under root k by m, radian per second. Like that I will do. Okay, and let's suppose they are asking the time period, 1 upon the frequency. So see, this frequency is what? In hertz. Always remember, sometimes they will ask the frequency in terms of hertz, sometimes they will be asking the frequency in terms of radian per second, right? So that is, you need to remember. And one more important, very very important point, while using this formula, a lot of students will do mistakes. What kind of mistakes they will do? See, they will do such type of mistakes, right? See, when you apply this formula omega n, under root k by m is there. What is the unit of k here? K will be in Newton per meter, but in the question they will give in kilonewton per meter. M should be in kg, right? So remember this unit. In the exam, definitely they will give k in kilonewton per meter, and directly you will put it kilonewton per meter, and you will get the wrong answer. So remember, never put k in kilonewton per meter or Newton per centimeter or Newton per mm like that. Newton per meter is the unit in which you have to put the value. Mass should be in kg. So remember this values. Okay, sometimes we know the formula but we put wrong values, so what you will get? The wrong answer only. Are you getting the point? Not so like that, you need to understand the things. Okay, I hope this point is clear to everybody, right? So now this formula is applicable for various cases also. Okay, I will explain those various cases also, just a minute. Okay, see, in this case also, let's suppose a inclined plane is there, theta angle is provided, this mass is there, and this mass is attached with this spring. In that case also, so in both these cases, this formula is what? Applicable. This formula is what? Applicable. Unit again, radian per second. Don't forget about the unit part. If they are asking in hertz, you will use the different formula. Okay, you will use the different formula. This formula, omega n by 2 pi. This formula you will use. Okay, remember this one. Right. Right. Some more important things that we need to understand here. Okay, very important for the GATE examination, right? Because initial readings, honestly, they are asking in civil engineering, longitudinal, transverse, and the torsional. T1. First is what? The longitudinal vibration. See, a rod is there and at the end a mass is attached, okay, like this. So in that case, if the vibration along the length, if I consider, that vibration is known as the longitudinal vibration. Formula is same again, K by M, but instead of using K by M, you can also use what? G by delta. If you remember what the case, K delta equals to what? Mg. From that you can write this K by M value as what? G by delta. So if anyhow, if you know the deflection because of this load on this rod, what is the deflection? That is what delta. You can directly get the value of omega n also, right? That is the point. That is longitudinal vibration. Second case is the transverse vibration. Transverse vibration like this. Okay, so now because of this mass, see now this is what the example of cantilever beam, okay, and a point load acting at the free end. So from strength of material concept, we know the deflection of the beam, right? So they will be asking what will be the transverse vibration if point load is acting like this, okay. So again in this formula also you can use K by M, but instead of using this formula we will use this G by delta, because delta value will calculate from strength of material, okay. WL cube by 3I, let's suppose the point load for the cantilever, what is the formula? WL cube by 3EI, that is what the formula we are having. So that is what the transverse vibration. And the third one, torsional vibration. Torsional vibration. How the torsional vibration will look like? See. Okay. Now, if I apply some kind of torque here, initial torque if I provided, obviously a torsional vibration will be set up here. Let's suppose this is the theta value. If I provide some angular disturbance here, so torsional vibration will set up in this case. Again, formula is same. Omega n equals to under root K by what? Here in this case, torsion, we will not put M here, we'll use mass moment of inertia value. And K will be what? Torsional stiffness. Okay. So very important point here. KT is your torsional stiffness. And obviously you need to know what is torsional stiffness, right? Not in the torsional stiffness, bending stiffness, axial stiffness, lot of things are there. See, in general, see, in this case, first of all, we will write the formula here. KT equals to what? GJ by L, or you can write it like this, T by theta. IM is the mass moment of inertia. That is what very basic thing. Okay. Now see, always remember this formula, stiffness. What is the formula of stiffness? Load divided by deflection. Are you getting the point? Load divided by deflection. Okay. So this is what the general formula. General. Okay, general formula. Okay, stiffness is equals to load divided by deflection. Like suppose I am writing torsional stiffness. What is the load? Torque. What is the deflection? Theta, angular twist. Like this we'll have. So from the torsion equation, we'll be able to write this thing as Gj by L. So that is what the torsional stiffness. If I talk about the axial stiffness, it will be what? AE by L. If I talk about this bending stiffness, it will be what? EI by L. Like this, EI by L, bending stiffness, right? So see, Gj by L, axial stiffness AE by L, and bending stiffness EI by L. Like that we can write the different stiffness. Okay. So I hope these points are clear to everybody, right? So see, in general, that which important formula is there? This stress, this stiffness divided by load divided by deflection. Whether the case of bending, the load is what? The bending moment. What is the deflection? You can calculate it from the strength of material basics, right? In torsion, torque is the load. Okay. In bending, the moment, bending moment is the load actually. In the axial forces, the stress, this load, the axial load is what the we are having as a load. In general, we are calling as load divided by deflection. Like that we can calculate. So I hope you got the point here, right? That is what a very basic things. I hope this is clear to everybody. But always remember this point. In general, stiffness is what? Load divided by deflection. Now, in the last we'll discuss a very basic thing, very basic point actually, the spring combination part. I know obviously that is what a very basic thing for you and you can easily calculate. So two cases are there. See, let's suppose if I take like this. Like this K1 and K2. So two springs are connected in series case. You will have a formula of K equivalent like this, 1 upon K1, 1 upon K2 like this. So this is the case A for the series and a case B for parallel. Okay. Okay, this is a case of series. This is case of parallel in which the springs will be what? Connected end to end. See, try to remember the difference between series and parallel. In the series case, see, what is the end to end connection? This is the end to end connection. End to end connection. So end to end connection will be in series case, okay? So end to end connection will be there in series case, but in parallel case, end to end connection is not there, okay? But what is the common thing? Deflection has to be what? Same. In the series case, deflection will not be same, but in this case, deflection will be same, okay? Because of the arrangement. In this case of parallel, you can write the equivalent stiffness as what? K1 plus K2. Like this. Like this. So I hope this point is clear to everybody. Right. Right. So that is what the basic part that we need to understand here. Okay. So see, we have covered almost everything in the vibrations also. Okay. You need to understand some basic thing like what is undamped, no damping is provided in the system, right? Like all those basic things you need to understand. And apart from that, if you see the previous year question, they are asking a very simple question in the civil engineering, right? Because this is what a very basic topic for you. So they will be asking very simple question. Just you need to ensure some basic fundamental things, right? So what are the basic fundamental things you need to understand? This formula, omega and under root K by M, right? This is the formula you need to understand. Secondly, what is the frequency in hertz? Like that you need to understand this formula. What is the time period of oscillation? That is the formula you need to understand. And while using the formula omega and under root K by M, you need to ensure K has to be in a unit of Newton per meter, mass has to be in unit of kg. Like this you need to understand, right? And for these cases also you will have the same formula. Because anyhow they will be asking the free vibration case. So this can be a case, this can be a case. Formula will remain same, right? And apart from that, three cases of vibration you should know. Axial, longitudinal, transverse and torsional. Longitudinal along the length of the member, transverse perpendicular to the length of the member, torsional vibrations lastly. So Kt by M, torsional stiffness we have to use, mass moment of inertia we have to use here, K by M bending stiffness you can use here, okay? But instead using those things, we'll use this formula under root G by delta. Delta is the deflection. We'll write here delta is the deflection of beam. Deflection of beam, right? So like that axial stiffness is there, okay? I hope this particular point is clear to everybody, right? So we have almost covered everything in engineering mechanics, which is for common part of mechanical and civil. Civil part is completed, right? We have discussed equilibrium, we have discussed thrust, we have discussed friction, we have discussed centroid moment of inertia, we have discussed vibration, right? So remember everyone guys, this point, remember this point. Thrust and friction has what more weightage, obviously, and obviously in civil engineering they will be asking a lot of questions from this one also, right? Every year they are asking, whenever they have added, I think they have added in 2021, in 2021 also, in 2022 also, in both the years they have added, they asked this question from the vibration. But apart from that, this friction is very important one, thrust is very important, equilibrium anyhow very easy for you. So most importantly, one of the most important topic in which mostly you students will what tend to do mistakes here is what the friction. So remember how the friction will be acting, in which direction it will be acting. For deciding the direction, what is the important thing you need to know? the friction will always oppose the relative tendency of the body. So you need to check first of all what relative tendency of the body, and after that decide the direction of friction. Friction will try to oppose that tendency of motion, relative tendency of motion, right? So I hope topics are clear to you, and this question will help you to build your confidence, and definitely you will do best in your GATE examination. Okay. So I hope you enjoyed the session very well, and from my side, all the best for your GATE examination, GATE 2023. Okay. Thank you so much.